to the fourth day of the summer school, and today we are going to have a very interesting session on social media data analysis from our resident social media expert, Morine from the UN Global Pulse Lab in Kampala. This should really be a very interesting session. And thank you for getting up very early to attend. So, Morine, I believe you're good to go.
Yes, I am, Shira. Good morning, everyone. I will just put my video for a bit and then switch it off just to get into the presentation. Welcome to this session, and I'll just get right into it. So just give me a second to display it. Okay, I hope you can all see my screen. Shira, could you just say yes for confirmation?
Yes, I can definitely see your screen.
Okay, all right. So my name is Morine. I'm a data analyst at Pulse Lab Kampala. Pulse Lab is a part of the UN Global Pulse, and UN Global Pulse is the UN Secretary General's initiative on big data, artificial intelligence for development, humanitarian action, and peace. My talk today is going to be about social media data analytics. Last Data Science Africa, I did a tutorial on how to mine and visualize Twitter data. You can find it on our GitHub account. And today I'll dive more into how to analyze and derive insights from social media data. And in summary, I'll focus on those things that I've listed there, asking rather social media data analysis metrics, asking the right questions that social media can answer, dealing with biases, how to turn data into actionable insights, and how to communicate those insights. But before we get into it, I want to encourage you guys to, of course, ask questions and then join the Data Science Africa forum on Facebook, where you can also start up some conversation there. And of course, tweet about our discussion. Don't forget to mention Data Science Africa, and our official hashtag for this virtual DSA is DSA 2020, and I wouldn't mind being mentioned. So my handle is right there at the bottom, the Amutorine as well. So I want to start with just getting into the basics. For you to do any social media analysis, you have got to have the audience or the users in mind. You can't just start doing an analysis without knowing who your target users are. And then it's always good to have a question that you're trying to answer. There has to be a problem for which you're trying to find solutions for. And then also at the initial stages, you need to decide if you're going to use, if you're going to mine and analyze data from first principles, that's use Python or R, or if you're going to find a self-serve analysis tool, and there is quite a number out there. So I have just put some materials on the right that you can look up. The first one is a course on social media data analytics on Coursera that is free. I like it because it is short and kind of to the point, that would show you how to do data analytics from first principles. It's with Python. And then the Brandwatch webinars have been so helpful for me as in understanding how to do social media analysis, because social media is evolving, and every day there is new things that are added that can make your analysis insightful. And so keeping up, those webinars have helped me to keep up with what happens in the analytics world, and how you can speak better to the general public. So I would recommend those for starters, for anyone who's willing to get into social media analytics. So why social media data analytics, one may still be wondering. Now, if you don't know yet, it has been observed and confirmed actually that information related to crises is released on social media sites before traditional news sites even get to show them, to publish them. This we have seen, and I'll give you an example. Here in Uganda, we have experienced a number of cases of flooding, and we get to see what is on ground through WhatsApp videos, even before the news channels get to air it. So social media gives one an advantage to actually keep out an eye. These days it's called social listening, having an ear, rather, they say an eye. Okay, yeah, having an ear to what is going on, so that you're, especially for timely responses in cases of a pandemic. And in recent world events, social media data has been shown to be effective in reporting natural disasters, detecting rumors, and identifying characteristics of information propagation. And while to some extent, the understanding of how social media can be harnessed and to optimally support emergency response, resilience, and preparedness is not well understood to some. We know that that is still the case to some. There is undeniable evidence that integrating social media as a critical tool in management, for example, the current in management of the current evolving pandemic, as well as transforming aspects of preparedness and response for future. For the future is really very helpful. And let me just say that the risk of ignoring social is high. So assuming that you have all the above in check, let's just get into some of the important aspects of social media data analytics and explore what can and can't be measured, how we should measure, and how to draw insights from what the data is saying. Now, we know that social media is a data intensive, messy, continuous, rather than episodic, and is characterized by increasing numbers of new behaviors that must be captured. But we can break all this mess of data into three major categories. And once you break this down, it should make your analysis a bit easy. So we know that on social media, we'll find conversations, we'll find people, and we'll find attributes that we can measure. I mean, like the likes, the shares, the emojis, which show what people feel about the content that is being shared. So those are the three core ingredients of social media. And the most core at the base is, of course, the people. Social media is made up of a pool of views and opinions of people that you cannot find anywhere else. And then conversations is the content, the topics of interest that people express on different social platforms. And then with measure, it's something that can be timely, and time enables us to know how the conversations are evolving over time. And so once you break down your data into these categories, it will help with the analysis process. Now let's look at some of the examples into these three categories that you can, the different examples in which you can actually analyze this well, which also comes into visualization. So I'll start with measure. Now with social media data, you're able to do a lot of things, but one of the things is you're able to gauge volume of conversation based on location. Assuming you're trying to look at a particular topic and see where is it most popular, or where is the conversation happening more than other places, could there be a reason why it is that way? So one area that you can look, that you can measure when it comes to social media data is volume of conversation by country. If that aspect is important to your project or analysis, then that is possible. Then of course, sentiment. I mean, you talk social media, you know, definitely sentiment will come in. So you're able to create, rather you're able to measure the amount of sentiment that is in social media data, and you're able to quantify the negative, the positive, and you know, the neutral. Now I've just put it in simple visualizations, and I know we have gone through visualizations. We did visualizations on the first day, so I'll not dwell much into the different visualizations, but that's just a small example of how you can actually visualize sentiment. You can quantify how much content is negative, how much is neutral, how much is positive, and that can give you the sense of how the public is perceiving your topic of interest or your brand. I keep talking about topic of interest because my work has been mostly topic, but in case you are doing an analysis for a brand, then you're able to quantify sentiment. Same goes for volume over time. You're able to, actually with volume over time, it's interesting because with volume over time, there is too much that you can actually get out of volumes. You're able to, for example, look at spikes, and then you can do an analysis around spikes. Why is there a spike here? And then, and those can be interesting for the analysis, and even you can look at shifts in volumes, and you are also able to derive, you're able to quickly evaluate the level of interest of a particular topic based on how it's performing in terms of volume of conversations over time. And then the final thing that you can do with measure is you can look at key insights. For example, you might be interested in knowing how many people are actually talking about this particular topic. If we took, for example, Twitter, how many unique authors or unique mentions are there of a particular topic? Because sometimes when I talk about unique, I mean, there are times when the same person keeps on posting about the same, and that might be, that might add to the numbers, but then are all the authors of this conversation unique? Because if they are unique, then that's what speaks to the volume of conversation, not the same. Like, you can't conclude that many people are talking about, let's say, locusts, when in actual sense, it's only like one news house or one organization or one person that has been posting, and that has increased the number of tweets about locusts. But when in actual sense, actually few people really are interacting with the topic of locusts. So it might be important to look at key insights, like who are the authors? Are they unique authors? What are the hashtags? How are they trending? You know, so that's what I mean by key insights. And that's what you can capture within measure. Those are some of, this is not all, there are more things that you can measure. So, but these are just examples of what you can measure about social media data. I'll go to conversations. Conversations enable us to do a qualitative analysis. Here we look at conversations by topic, and we can quickly gain an overview of the nature of the conversation in the data set. You're able to explore relationships between topics and then subtopics and that are within them. And then you're also able to look at most popular topics for entities such as people, location, or organization. You're also able to identify topic trends within conversations. And you're able to see what are the latest trends, like what are people talking about these days when it comes to locusts. And you're able to understand which topics are fading out. And all this could be informative to your analysis, again, based on what question you're trying to answer. So you're able to rather to determine what terms are associated with a topic. And in this is where we usually draw, we usually do have like, let me try to annotate and see if my annotate works. Can you see my mouse now? Oh, okay. I will continue because I don't know who should respond. Yes. So in this, when you're looking at topic terms related to a topic, is where you usually do visualizations like the word cloud, because you're looking at floods, but then you're looking at what are the terms that people are using when it comes to floods. And then with conversations, you're also actually able to do sentiment of topics, and that's where you usually do find visualizations like the topic wheel, where yes, people are using all these words, but then what is the reaction like? Are they positive about the topic? Are they neutral about the topic? Or are they, and then also you're able to geotag mentions, like to be able to see, okay, this kind of conversation or this kind of talk is coming from this particular area. And then this is what I talked about, topics which are trending and those which are fading out. Like analyzing conversations in particular is where you're able to come up with such visions. And with analyzing conversations, you have to know that sometimes you actually need to read through the, in fact, not sometimes, all the times, you need to read through the conversations themselves, the tweets that you have mined. And then once you have read through them, then you can actually train your classifier to be able to identify the things that your mind is understanding. Now, these are some of the things that the self-serve tools have made easy. They can classify much faster than how you would be able to do it, let's say with Python, because of course they have experience and their methodologies have been tried and tested. But it can also be done from first principles, where you read through comments, understand the conversations, and then you're able to actually classify things into topics, and then you're able to identify topics which are trending. All that you actually get by really getting your hands dirty and diving into the content and reading through it. Now, the last thing that I'm going to talk about, okay, looks like I need to first exit this, and I can go next. Perfect, yeah. The last thing I'm going to talk about when it comes to social media data is you have an opportunity to also do an analysis around people. Demographics, what are the interests of male compared to the interests of female, trying to compare those kind of different demographics would also be interesting, depending on the kind of the analysis that you're doing. Then we have, you can also look at unique authors. I talked about those earlier. And then also sometimes you need to go in and see actually who are the top authors. The top authors part is important for if you're doing an analysis for brands, because then you're able to identify, for example, who would be the suitable people to do your influencer marketing. Yeah. So that's how you can leverage on the people aspect of social media data to actually come up with an insightful analysis that that can be helpful to an organization, because a social media data analysis exercise is successful if the insights have been used. If they have been able to inform decision making, and then the management or whoever is responsible is able to take action, you know? So it's important also to know who is talking about the brand, let's say, across different platforms, which would help us, of course, with identifying influencers for brands. But then also sometimes it's looking at people in detail for analysis can be informing of your analysis altogether, because one thing that you know about social media is people go to social media just to put out their opinions, their views, or just to show how they want to be perceived by the people, maybe their followers or whatever. No one ever goes to tweet or on Facebook to create data for us to analyze. So it's important to understand that, rather it's important to look at the demographics so that you know how that affects your analysis. People are just there to do their thing, but then for us, we are here to say, can we pick something important out of what is being conversed or what is going on? Now, all these are opportunities of things you can find within social media data, and you can, you'll like we've seen, you'll be able to identify trends, you're able to do sentiment, new opportunities of different ways of analyzing data, and then you're able to identify potential crises and more. But remember, your analysis is ultimately shaped by the question that you want to answer. And that brings me to our next target, which was about how to ask the right questions that social media can answer. Now, you need to understand that when you're a data analyst, and in particular a social media analyst, the questions that will come to you, the people that will come wanting work, or the questions that will come to you, to your mind, will be real world problems. Your first step is to turn a real world question into a question that social media data can answer. In fact, some analytics experts advise that we should spend a good amount of time finding the right questions before getting into the analysis. In some cases, this could mean spending more time defining the question than doing the analysis, depending on how hard or tricky the world problem actually is. So social media data analysis is about tweaking business questions to questions that social media data can answer, then relating those to the business questions. So you get a question like the one that you're seeing on the screen right now: how can I make more people buy more of my cat food? You know, like that's the problem that someone would ask you as an analyst. So then how do you ask the right question? Or how do you tweak that to be a question that social media can answer? I mean, full screen presentation mode, I wish I could see, I could ask you guys to put some of your thoughts in the chat or Q&A, so that, you know, you're able to like think about it and see. Someone has come to you to do that. How do you actually turn that into a question that social media can answer? So feel free to actually write some of your responses. Maybe Shira will read them out. Feel free to interrupt me, Shira, to read some of the responses that come up.
Okay, will do.
Yes, but I'll still go ahead and continue and come up with and share with you some of the questions that I thought would be answered by any social media data that you find. And then those questions you can actually be able to turn back and relate them to the real world problem that the person, that the client is asking for.
So do you want to give them a minute to share what they would?
Okay, let me give a minute then. I had just displayed some of my thoughts, but let me know when I can start again.
Yeah, let's give them a minute to put something in the chat. So kindly, how would you ask social media about cat food? Maybe we don't have any cat lovers here. Maybe Morine, maybe.
No problem. I will just go ahead and give you some of my thoughts, but please go ahead and think about what your responses would be to such a question or even a similar one. So one way of rephrasing that question into something that social media can answer would be, how can I increase or elevate my shallow voice about cat food? You know, now that social media can give you a hint, or how can I identify cat lovers on social media? You know, that's something that social media can show you, because with social media data, if you mind anything that had in cats, maybe you will see where do people chat more about or talk more about cats. Those would be your target people. So this is just a simple question that I thought about, but the real world problem should just be a starting point for you now to start thinking, what are some of the questions that social media data can answer that I can relate back to the real world problem? Because think about it, if you identify who the cat lovers are, for a brand like this person who is selling cat food, then they will be able to make content that is tailored for those users and even target them, because now social media allows us to target, you know, to target who sees your content. That way, you're actually you're actually able to increase, you know, it's like it's possible that once you have identified the right people, you've given them the right information, then they will be able to buy the cat food because now they know about it. So that's what I mean by asking the right questions that social media data can answer. I don't know if anything came up here, or I go on to the next.
Yeah, there's some contributions. There's Hallelujah says category of those interested in buying cat food, and category of people interested in buying cat food. There's a contribution about, I don't know whether, what are the perceptions of Ugandans regarding COVID-19 management by government? I think maybe that's a general question social media could answer.
Yeah.
Then
yes.
Post images or small videos showing people playing with their cats.
Exactly.
As well as their cats eating food.
Exactly.
Those are the contributions.
Yes, that's good contribution. Thank you, guys. Because then if you're able to identify people who are posting videos about cats, then that means those are the cat lovers that you need to identify, that your client then can actually target with their content so that their cat food is known to them. The same goes for looking for the category of people who are posting about cats, then you're actually identifying cat lovers. So you may not necessarily directly answer the question that the business or the real world brings to us, but rephrasing it and then looking at those different aspects. And by, mind you, looking at, one business or real world problem can translate into a number of social media answerable questions that then get to form your analysis story or analysis results that you get to give back to this client that is interested in, you know, how can I increase my sales or people knowing that I actually have cat food. Yes, so I'll go ahead and say that as a data analyst, your role is really to turn data into actionable insights. And how you do that, how you turn your social media data into actionable insights is in a number of ways. I'll just go through probably 2 or 3 because I realize we also have to have I have to answer some questions, so I don't want my presentation to take long. So how do you make sure that your data is actually insightful and it turns out into something, rather your analysis is insightful and it turns out into something that can be used? The bottom line, the core, before we get to how you even get to show how you get to share your analysis, is the core is the methodology that you have used to mine, to analyze, and to go about your data. Now, methodology is key in recognizing the potential flaws and the ability for the analysis to actually, for the insights that you have come up with to actually make impact. Now, what I mean by methodology is we all know that once you mine data and you're starting to do an analysis, you could have made a compromise or call it an assumption. You know, you mine and you get all this bunch of data and you have to make some decisions because the data won't provide you with your ideal imagination of what you wanted. You're mining for locusts and you're hoping every person that is reporting about, is tweeting about locusts is probably, is going to be talking about how locusts have affected their let's say what, their food or their farming or their, you know, you're assuming that that's what they are going to tweet about. But then you get online and you find people are chatting about, you know, all sorts of random things. You know how on social media we like to be funny and almost everything we share, we're putting a bit of humor into it. Now, you might make some decisions where you say that, for example, if I find anyone is using this particular word in their tweet, then I will tag this particular post as, let's say, relevant or not relevant. Now, understanding that the kind of compromises or the kind of decisions that you have made while analyzing data are important even as you come up with your insights is crucial, because then it is able to cater for what are they called, it's able to cater for the compromises that you made. What do I mean by that? That if the person supposed to be using your analysis or interpreting the analysis, because usually we do the analysis and someone else is supposed to use it to actually inform management and be able to, the one that makes sense of the results of your analysis. That person being able to understand as well that these are some of the compromises or these are some of the assumptions that were made is helpful in them actually coming up now with what we can term as the guidelines to the management who are supposed to make a decision. So without you validating your methodology, you risk really invalidating a whole data set. Because imagine if you gave someone an analysis and you said, you know, from according to social media, I think many people actually love cat food. And yet in actual sense, some people are just doing memes and they find them funny. So being able to decide that, okay, whoever shares cat food I will take them as a cat lover, but then does it mean that they actually own cats, you know? So being able to specify like such an assumption and saying this demographic or this group of users could be a potential cat lovers, but then these have shared just cat videos. I'm just using that example for this explanation, but it does not necessarily mean that they all own cats, but there is an interest. Now that makes your data more, rather your analysis more insightful. Why? Because it's taking care the assumptions of the, what I'm saying is we should not forget our assumptions. We should not forget all the compromises, all the decisions that we have made when we are looking at data, because like we're going to see in the next slide, is there are biases in ways that we actually, as humans, there are biases in ways we look at data. Sometimes we look at things the way we would want them to be, and hence that has effects on our results, on what we produce from the analysis. So beware of biases is the next thing that I was going to look at. Bias literally is looking at interference in the outcomes of a research by predetermined ideas, prejudice, or influence in a certain direction. Now, data can be biased, which we have already looked at, that you have to take care of within the methodology, but so can the people that analyze the data. Let's take an example. The first bias that you're looking at there is the selection bias. It is important to get the sample size right based on the number of factors that you deem important. You're interested in knowing, for example, what are people's conversations about floods wherever you are. It is important to put some factors in perspective. How long or how far back do I want to mine the data? You know, for which regions? Maybe you're looking at areas which have been affected by flood, you know. So what I'm trying to say is, for example, a large sample size of data is not better sometimes. Be sure who you want to listen to and ensure they are representative of the analysis that you're interested in, or else you risk selection bias. The other bias that we can look at is response bias. For those who work in teams, sometimes people might tell you what they think you want to hear, you know? And for social media, users write messages intending to please or speak to the audiences, not for your own research. I think I mentioned this earlier. So people will post content on Twitter anticipating response. You know, you write a comment knowing that, yeah, people should be able to respond to this, you know, in a particular way. And they could portray different interests from what they truly are. So you might never know which users are faking it or who are real, but having that in mind, knowing that sometimes this, you know, that I think that's what in data science altogether we call the level of accuracy. Like you should be able to tell the level of accuracy of your data and hence your analysis. The last thing about biases, and I haven't gone through all of them, I think I have a link somewhere at the end about also where to see more about biases, is confirmation bias. And this is about the very human characteristic of wanting to hear what we want to hear. It's even worse in people who have not been trained in good methodology, good data analytics methodology, because then indeed you look out for what you want to hear. Social media is a bag full of messy opinions of millions of people. And when we are researching, there is a tendency to look for results that confirm our worldview of things. And I want to tell you that it is actually a skill to allow yourself to be surprised by the data and not try to influence the data yourself. So yes, beware of any compromises made, and of course, those can bring about biases. That is the link with more about biases. When we share the slides, you'll be able to copy and find more about biases. Okay, the other thing that I want to talk about, how you can make your data more insightful. You have already taken care of your methodology and you know your results are valid and won't be invalidated by the decisions or compromises that you made. The other thing that you can look at that is important is looking out for data that you can compare with your results. You found this particular finding on, let's say, in your Twitter conversations. Does any other data set correlate with it that would make your story more compelling? And this, I'll give you an example. So what you're looking at are two graphs representing the volume of searches and tweets of similar search terms. And the terms are coronavirus symptoms, coronavirus causes, coronavirus treatment, and then spread and cure. Now, to give you a bit of context, I recently analyzed Google searches Google search suggestions data to uncover what people in Africa are searching about the novel coronavirus. By exploring the different queries, I noticed many were about symptoms or indirectly portrayed a confusion about the symptoms of COVID-19. Like the searches about COVID were up there. So I thought it would be interesting to look into how queries about symptoms compared to other aspects of COVID-19, like compare those two and see how that would look. And so I went to Google Trends and did the search, which is what produced the graph on the left, the Google search data. And it shows that coronavirus symptoms were indeed most searched compared to the causes, to the cure, and the spread. That is this graph on the, let me try to annotate just to be clear. That is this graph right here. This one, oh, okay. This annotation is special. Anyway, that is the Google search data graph where I went and searched. I just put in these terms right here. If you've used Google Trends, you know that you can search for different terms and then it gives you the volume of conversation. Now, for the sake of this point and this presentation, I went ahead and ran a few queries on Twitter data as well to see if what people searched about, which is what I found about from Google, had any correlation with what people were actually conversing about on Twitter. And to no surprise, the graph on the right shows that symptoms were discussed more than causes and the cure on Twitter as well, in exactly the same time frame. Because if you can see this map very well, the green one represents COVID-19 symptoms. These are just labels, but I searched the exact same words: coronavirus symptoms, coronavirus cure. I was using coronavirus and I just labeled this, but you can see that still symptoms are up, just like symptoms were up here in the case of Google data. Now, comparing your social findings with other data sources makes your analysis even more insightful. It really helps you to draw conclusions, because now you have data that can actually support each other. So whenever you have findings from your social media data, then it makes sense to actually look out for other data sets that can inform in the same way, and then you're able to compare. Is there anything that actually rings a bell that can make sense, you know? And so that is just a different way in which you can make your data more insightful. Look for data that you can compare it with. Now, I don't know if I can go ahead, clear all drawings, and then I'm able to. Okay. Now, the next thing that I'm going to talk about is actually trend spotting, which is more or less the same as comparing from up that we've just covered in the previous slide. Once you've done your analysis and you've identified some trends and some shifts in volumes of conversations, or even some topic trends from your social media data, it's always good to go trend spotting, for example, from news outlets, from news articles online, which will be the same as what I was saying. You're looking at a different data set that can actually support what your data is telling you. Combining data sets can help you reveal external factors which are in play and can help you build a good data story, really. And lastly, I just want to mention that whereas you're comparing things, sometimes also it's good to pay attention to relations that bring about causation. What do I mean by that? Sometimes you can identify trends, and then you can identify relationships within the data, and then you're able to decide maybe because of this could be why this is happening. I'll give you an example. If you're looking at a correlation, let's say between retweets and tweet sources, it can be insightful in identifying, again, influencers for social media marketing. Because if you realize someone tweets a lot, retweets things a lot, and then those retweets actually lead to more, like being able to see which relations bring about a result can be insightful for your analysis, is what I'm trying to get to. So there are more ways that you can make your data more insightful. Sometimes you just have to look out for surprising data. You find what we usually call like outliers. Sometimes it's interesting to actually look at something that surprises you. You know, something that is eminently surprising that comes out of the data. It could be a good story, or it could be a good analysis point based on what your the intended outcome is for depending on the question that you have. And sometimes where context is needed, and I will emphasize this, that really it's where context is needed, it is okay to actually display some tweet content to give your statistics context. What I mean by that is sometimes you put out statistics there, maybe in a good visual or in a good infographic, but then you feel like it would be interesting, or rather it would be helpful for someone to look at some of the sample tweets that were actually put across. And you come up with good examples that you can actually display on your dashboard or in a presentation to give context to your analysis. I mean, for privacy reasons, this is not the best practice, but then there are ways around how you can anonymize some aspects of a tweet to make sure that it's not implicating. And also, I think depending on the kind of analysis that you're doing, some tweets are literally harmless, and it's okay if there is need for you to give context to your statistics to actually provide some of the tweets that you came across. Now, I know I've talked a lot. I hope I have not lost you, but I'm almost to the end of my presentation. And the last thing that I want to talk about, and I will not dwell much into it because I know you've covered it, is how to communicate your analysis insights or your analysis results. And this definitely, you looked at how to do data visualizations, so you know how to communicate analysis results. But I just wanted to emphasize on one way of communicating data insights, and that is data storytelling. Forbes defines data storytelling as an approach of communicating insights, and it involves a combination of three keys, that is data, visuals, and narrative. It is important to bear in mind that while some people may respond better to one way of presenting data or presenting your results, one kind, hello? I feel like I'm hearing people. I don't know if someone is trying to say something.
Yes, I think it was a spurious mic went on. Yes, go ahead.
Okay, please, yes. So I was saying that it is important to bear in mind that while some people may respond better to one way of presenting data, another kind of person may respond better to a different way. And I think part of being a good data analyst is to appeal to people who respond to information in different ways and not being biased by your own preferences. The storytelling technique applies to both presentations and displaying results on dashboards or blogs and etc. So a core data-driven narrative will include the different things that we have already talked about. We include trends, comparisons, relations, and correlations, or surprising or interesting data that you come up with, but then it will also include a well thought about script that makes your data a bit easy to understand. It's important to do data storytelling because it keeps the audience engaged, you know, and the data you and it gives your data a chance of you know, coming up with impactful visuals that people can relate with once you're able to combine all those, the three, the visuals, the data, and the narrative. So usually for you to come up with a good, and these are just a few tips that I usually do when I'm doing an analysis, is to come up with a good narrative. Is you will need to start with like an overall picture, give a few insights, summaries of numbers of the things that you have come up with, and then you can dive into the different categories of things that you deem important and give details. Like give someone an overview, just like, you know how you usually writing a paper, you give an abstract, which is literally what the whole paper is all about. So you give an overview of the findings, and then you're able to dive into the details. Remember, not all findings are interesting or informing of the topic. So it's also important to familiarize yourself with the topic that you're trying to analyze, rather to do analytics for, and then you know what would be interesting to put in your insights. And then, like I said, remember to explain your analysis with a well thought about script. I think the problem that we have as data analysts is we know, get data, visualize it, and that's it. But it's good to actually come up with a thought about script that will explain what you came about with very well. And I'll just say finally that it's important to educate yourself of the visual presentations that capture users. I mean, learning things like how the human mind processes things, colors, sizes, and etc. And if you're interested in, this is just a summary of what I was talking about, the narrative, the visuals, and the data for data storytelling. So finally, I hope this is my final slide, is if you're interested in scraping some data and maybe practicing some of these things that we have talked about, like I said at the beginning, last Data Science Africa, I did a tutorial about scraping Twitter data and visualizing it. It's such a short one that it gives you data that you can play with in a short period of time. So that's the link to it that you can find in the previous Data Science Africa website page link, rather. There's a link to the materials of the last Data Science Africa. You'll be able to do the analysis from first principles with used Python. And then if you are interested in continuing, you know, this data analytics exercise, you can take that course if you don't know where to start, the free course that I talked about. The details were on the second, I think, or third slide. And then I'd encourage you to explore social media data analytics with self-serve analytics tools. A good example would be Brandwatch. Some of the advanced analysis analysis functionalities are commercial, but there is a bit of it that is free that you can explore with. There is also BuzzSumo that you can look at. And with this, these tools will help you learn new ways to interact with your data and how best to present it. I think sometimes it's important to look at how people are analyzing and reporting on their insights, and then learn how to best do yours as well. And I think that's it. That's it. I can now take questions if you have any. Thank you.
Yeah, thank you very much. I think you can see the Q&A, right?
Okay, so let me see.
There's a question by Andrew about any experience to share on handling sarcasm or irony in tweets.
Oh, okay. Okay, I need to first exit my presentation view, I think. Okay, now I can see the Q&A. So you said there's a question about how to deal with irony. So with irony, again, it depends on how you want to categorize your data. That also depends on the question that you're trying to answer. If the question is about identifying volumes of conversations, even if there is irony in a tweet or in any sort of post, you're able to decide on if you want you want it to be a part of your data set that you're analyzing based on what your question is. Sometimes the questions you're the question you're trying to answer is as simple as, are people talking about this? If they're talking about it, what are they saying? You're just looking for people's perceptions on a particular topic. Now, even if it's ironic or not ironic, it gives you a feel of what the person is saying. And that's why it's important, I think, sometimes to read through these messages yourself, because then you're able to see that this is ironic, but still it shows that someone is interested. You know what I mean? So if you're interested in like volumes and whatever, then yes, you will have to include irony because that's someone talking about the topic and it informs the topic. But then if you're going deep into understanding how such an opinion affects your topic, then you might want to label that as not relevant and probably the next one. So it all depends on the question you're trying to answer.
There's another question from Francis. Do you want to unmute and ask it yourself?
Hello.
Yes, Francis.
Okay, I just wanted to ask, like, I mean, a large part of Africa, they don't have smartphones or Facebook or Twitter. How can you do like social data analysis, you know, just using data like SMS or WhatsApp?
Oh, wow. Okay, now those are data sets that I haven't looked into, SMS and WhatsApp, because then also two things you have to look at. One is, I feel like people use SMS to communicate about specific things. So I don't know how specific that kind of analysis would be where you're interested in analyzing people's text messages. WhatsApp, on the other hand, is used to share things, you know, all over the place. And again, also looking at that type of data set that WhatsApp would be, it's highly private. So I don't see any way that we are going to be able to tap into WhatsApp messages anytime still soon. I don't know what it will be in the future, but I don't see us, you know, being able to tap into that. But then just the second point that I wanted to come to and to just tackle the point of people, not many people in Africa are on social media or are on have smartphones, is that's also one of the things that you have to put into consideration once you're doing your analysis. So you know that social media represents this much population of Africa, and it represents, you know, people who are in this particular age group, people who are in this particular financial status or you know, you have to keep all those things in mind. And those actually inform what I talked about earlier, how insightful your analysis is. If for the analysis you're doing, you're interested in a group, in a demographic of people that is not represented on social media, then definitely social media is not the right data set for that kind of analysis. You know what I mean? So it's important to keep also those facts in mind, because by doing social media, you're just representing the demographic of people that are actually able to access, that have smartphones and have social media. Yeah.
All right, thank you so much.
All right, thanks, Maureen. We'll give you a virtual clap. As we,
Thank you, Shira.
That's actually a real clap.
I had it, yeah.
For the next session. I believe the next session is, I see the presenters are on. We're going to be hearing from mechanism design, the group mechanism design for social good. I see Rediet there, Irene, Lo, Francisco. I think that you're all on the chat, right? Though we had a presentation that I believe was to be played, but since you're on, I'd like to let you maybe first speak. Ready? Are you on?
Yes, I'm on. Can you hear me?
Yes, we can hear you. Thank
Very
you very
good.
much.
Very good. So we can.
Okay, go ahead.
Okay, very good. Very good. Thank you so much. It's really wonderful to be here. Thank you all for organizing the summer school and the workshop, and inviting us especially. We've been wanting to take part in Data Science Africa for a few years now, and while the virtual format and the time differences are not ideal, we're very excited to be here. So I just wanted to start by saying thank you. So what we have planned for you today, so as Shira, as you mentioned, we have a lot of speakers. So what we have planned for you today is a quick introduction about the Mechanism Design for Social Good initiative, which Irene Lo will be giving. And then we'll have 4 presentations. They're going to be short presentations, about 20 minutes each, that will be on 4 different topics that members of our Mechanism Design for Social Good community have been working on. So that's what the plan is, and I'll plan to kind of help with the transition of the talks, some of which are recorded, and we'll also have time for questions as well. So that's the plan, and with that, I'll introduce Irene Lo, who's a co-organizer of the MD4SG initiative. She's a valued collaborator to many of us on this call. So it's a very familiar name for many of us, and she is a professor of management science and engineering at Stanford University, and she'll tell us a bit about Mechanism Design for Social Good.
Thanks, Rediet. I'm just going to take a moment here to set up my screen. Let's see. Okay, great. Do you all see the slides?
Yes.
Okay, great.
Yes, I see them as well.
And I think I cannot see the chat while I'm presenting. So, Rediet,
I'll keep track. Don't worry about it. Yeah.
Okay, great. Well, thank you again, everyone, so much for having us here. As Rediet mentioned, we've really been looking forward to working with you all at Data Science Africa, and we're really excited that we were able to join you this year, if only virtually. And yeah, so I'm just going to give you a brief overview of what Mechanism Design for Social Good is about. And Mechanism Design for Social Good is currently organized by Rediet, myself, as well as Anna and Francisco, who are also on this call. So what is Mechanism Design for Social Good, or we call ourselves MD4SG? MD4SG is an interdisciplinary initiative using techniques from algorithms, optimization, and mechanism design, along with insights from other disciplines, to improve access to opportunity for historically underserved and disadvantaged communities. And so actually MD4SG grew out of a small informal reading group that Ready It and our friend and collaborator Kira Goldner started when they were both PhD students. And so you can see at this table, most of the members of that initial reading group, 10 students, 2 professors, reading about problems or potential application areas of the techniques that we knew how to use. And in the past 4 years, it has really grown exponentially to a group of over 1,000 people in over 100 different institutions and 30 different countries. And so we're just really excited to see the trajectory that this humble reading group has taken. So what is MD4SG about? We take a multidisciplinary and multi-stakeholder approach to tackling problems impacting disadvantaged communities. And to do this, we try really hard to bring together people from different disciplines, different countries, people outside of academia, such as policymakers and government organizations, non-government organizations, and very importantly, also the impacted communities in all of the problems that we're trying to tackle. And so another way to sort of frame this is we're trying to bring an end-to-end approach to tackling and addressing issues of improving access to opportunity for historically underserved and disadvantaged communities. And so in order to do this, we think it's really important to bring together multidisciplinary collaborators, including people from algorithms and optimization. So basically all of you at Data Science Africa, as well as people from other disciplines to diagnose the problems and to co-design solutions. And then also multi-stakeholders, so different institutions, different countries across the world, different affected, as well as the affected communities themselves, so that we can really define the problems well and make sure that we're tackling the right problems. How does MD4SG do all of this? Well, we have a lot of activities, and I'm just gonna briefly highlight these 4 for you now. The first that we have is a monthly colloquium series. This is fully online. And in the colloquium series, we bring in speakers to talk about exemplary examples of previous work that they've done in this area of mechanism design for social good, or also to draw high-level connections for us. And so just as 2 examples, we had a wonderful talk by Dr. Abase from Research ICT Africa, where she told us what not to expect from ICTD research. So essentially, if we were thinking of engaging and using ICTD techniques and ICTD research in order to design solutions for disadvantaged communities, then what can we expect and what should we not be looking for in this process? And so, yeah, that was a really fantastic talk, which also highlighted this emerging intersection between MD4SG and ICTD. Another talk we had was from a Nobel Prize winner, Al Roth. And so he talked about how market design is more complicated than mechanism design, and so is achieving good social outcomes. On top of that, we also have a Medium blog, and in the blog, we sometimes highlight some of these colloquia. So we have a post summarizing Dr. Abase's April colloquium, if you're interested in reading. And we also post all of these talks, well, most of these talks, on our YouTube channel. Our second set of activities are our annual workshop, as well as events at other conferences and workshops throughout the year. For example, this event that we're doing right now with all of you. And so here are some of the events that we've had. We have an upcoming standalone workshop, MD4SG 2020, which we're very excited about. But right now we're here with you at Data Science Africa. And yeah, here's just some of the other events that we've had. The third set of activities we have are working groups. And these, I think, are really the core, the heart of what makes MD4SG MD4SG. And so we really want to bring together academics from different institutions and also collaborators who are not academics from all sorts of different backgrounds to be working together regularly. And so the working groups are the main place where people can engage regularly. Most of these working groups run bi-weekly and they're domain specific. So the working groups we have right now are for developing nations, environment and climate, bias, discrimination and fairness, data economies, and global perspectives on inequality. So groups of researchers gather together to explore together what are the issues in these domains, what are the tools that we as different researchers have to try to understand and tackle these issues, and how can we be working together. And so a lot of these working groups are also working towards joint projects or survey papers, you know, other sort of academic output that really needs us to be coming together regularly. And so I think this is something very unique and distinctive about MD4SG. We don't just meet once a year to talk about what we've done, we actually work together as a community. Yeah, so just saying all of it again, we really think that the working groups are the core of MD4SG and the backbone of our community. And they bring together researchers and practitioners. Right now, there are in our working groups over 200 participants from over 20 different countries. And their goal is to arrive at a shared research output or direction, or yeah, to sort of come up with a research area or a purpose that they all want to be working towards. And so what we're going to be doing in the rest of today's presentations is having some of the working group organizers come and tell you a little bit about what they've been doing in those working groups.
Thank you so much, Irene. Martin, would you be able to play the first recorded video? So now we're going to show you a video from the first working group, which is the Climate and Energy Working Group. And this is a presentation by Wanyi Lee and Lily Shu. And Lily Shu is actually on this call, so she'll be able to answer our questions, but we'll play the talk as a pre-recorded talk. Thank you.
I'm not sure if others are hearing it, but I'm not getting any sound.
Yeah, I'm not hearing the sound either.
I think upon sharing screen, it looks like Martin is sharing the screen. You can also have the option to hit share sound as well.
Hi, everybody. My name is Lily Shu. I'm a PhD student at Harvard University.
Hi, everyone. My name is Wanyi Lee, and I'm a PhD student from Stanford University.
And we're the co-organizers of the MD4SG Working Group on Environment and Climate. We're very happy to be part of Data Science Africa. Thank you for letting the MD4SG network participate. And we're very excited to share what our group has been working on, and also just talk about general opportunities for data science to help with environmental and climate issues. So just a quick overview of what we'll be discussing today. We'll be motivating the climate problem, and specifically related to climate justice. We'll talk a little bit about our working group, the members that comprise our group, and what our mission, our focus has been so far. Discuss a little bit about climate change and solutions. Talk about opportunities for data science, and look specifically at challenges and opportunities for Africa. So first, let's look at climate change and climate justice specifically. So the mission of MD4SG is to improve access to opportunity for historically underserved and disadvantaged communities. And first looking at the statement, it might not seem that environment is directly related to this mission, but upon greater examination, it truly is at the heart of this mission. So climate change will impact everybody, but unfortunately, global warming and extreme climate events will more disproportionately harm communities that are already marginalized, and particularly in developing countries and populations that don't have the means to move to other locations if sea levels are rising, and also countries that are based on agriculture and fishing, particularly coastal cities near the equator. These are the areas that are going to experience the most sea level rise and change from extreme climate events. And the struggle is that those communities are not as resilient to adaptation to changes. And one particularly important aspect about climate justice in this situation is that these developing nations and communities are unfortunately the people who have contributed the least to the climate crisis. So these are the regions that have emitted the fewest carbon emissions, but they will still be the most impacted. And therefore, what we're trying to highlight is that sustainable development challenges are intersectional, both with societal groups and also with other challenges such as environmental, agricultural, and economic. So our working group on environment and climate has focused on giving an overview between presentations from our group members and external readings to try to understand specific challenges for the environment more in depth and look at potential solutions. So the composition of our group, we're fortunate to have sort of a larger base, but around like 8 to 10 core members who span diverse geographic locations throughout the United States, Europe, specifically France, and Africa, specifically Nigeria, South Africa, and Tanzania. We are also a multidisciplinary group spanning computer science, economics, agroeconomics. It's just coming up slowly. Engineering and operations research. So one of the things that we've looked at as a group is Project Drawdown. So Project Drawdown is a non-governmental organization that focuses on quantifying potential climate solutions. So their approach is to look specifically at listings of different climate solutions and do an economic analysis both on the cost of implementing these solutions, but also the potential savings. And what you'll notice in this chart is the savings actually which are $74 trillion, in US dollars, far outweigh the cost of these solutions, which hovers around $30 trillion. The reason for this is climate solutions such as more efficient energy and retrofitting buildings to provide better insulation, for example, and turning to other sources of energy and changing our transportation network, all of this will have energy and cost savings in the long run. So we might have to make an early investment, but over time, the investments will pay off more than what we pay for. And what is particularly notable about Project Drawdown that we really enjoyed, really appreciated as a group, is they take a very quantitative analysis looking into the potential climate benefits of each solution. So they look specifically at the reduction in carbon emissions in the CO2 equivalent shown here for each of these solutions. So this pie chart will is highlighting what the most beneficial solutions are in terms of carbon reduction. So we'll see here that refrigeration is the number one, but there are also many things that we wouldn't think of as immediate climate solutions, such as educating girls and family planning. That will, by educating girls, for example, we'll be empowering them to, girls who are often smallholder landowners, to more effectively farm on their land and provide better climate and land management, which will have environmental benefits in the long run as well. So we're going to be discussing a few projects related to other things we've discussed as a working group or things that our working group members have worked on. But we want to highlight throughout this that there are many opportunities for data science. So the challenges in these environmental domains is that we have limited and incomplete data. It's often costly to collect new data. And we also have limited resources. So we have to figure out how to effectively allocate these limited resources. But in each of these challenges, poses an opportunity for computation for data science. So for example, we can work to quantify the social, economic, and environmental impacts of climate, such as what Project Drawdown has worked on. We can also work to monitor environmental conditions, which would often be very costly and would need to send people out to locations all over. But with technology such as satellite imagery, we're able to do that much more effectively. And we also want to understand consumer behavior so that we can, for example, better manage our energy loads and migrate to smart cities and smart infrastructure.
Thank you, Lily. So now we will spend the rest of the talk to discuss a few challenges and solutions that we as a group have identified that we believe are important for the African continent regarding to climate and environmental frontier. And a lot of these challenges and solutions we'll be discussing will echo back to the Project Drawdown solutions that Lily mentioned earlier and the opportunities for data science. And we'll also be mentioning some active and existing working projects done by our working group members. So to start, I think the most important thing to discuss related to climate and environmental challenges is the smallholding farmers and agriculture. Population-wise, we know that more than 60% of the population in the sub-Saharan Africa are smallholder farmers, and smallholder farmers themselves constitute to are doing agriculture on more than 80% of the farms in Africa. And we know that almost a quarter of the GDP comes from Africa, comes from agriculture. So they are a really important part of the economy, the culture, and the social aspect of the continent. So so there are a lot of challenges in agriculture, but one thing we want to emphasize here is thinking about what are the sustainable agricultural practices that are available to the farmers. So we know that there are agroforestry, which are particularly helpful for farmers in East Africa. And there's various ways to do water, soil, and pesticide management that can decrease cost and improve the agricultural productivity, improve the agricultural productivity, and at the same time, it will help with sustainable development goals. And this is to note that a lot of these sustainable agricultural practices deal with climate change in two ways. One, they are the mitigation strategies, and second, they are adaptation strategies. When I say mitigation, we mean that this will help to combat climate change by reducing the greenhouse gas emitted into the atmosphere that's caused by land use causes, including agriculture. And the second thing is that they're adaptation strategies because they help farmers to better adapt to a warmer climate. But no matter what we're doing, in the end, we have to emphasize that the smallholding farmers are the most vulnerable population in dealing with climate change and environmental degradation, because these extreme climate events harm the agricultural productivity and really affect the outdoor working conditions that the farmers face. So a lot of the projects that people in our group have been working on are related to smallholding farmers and agriculture. First, I want to emphasize a working paper that's started by a series of discussions we had for whole group, and now Lily, Paul, Tim, and I have started a project on sustainability certification for smallholders, which is that how do you get more how do you encourage more smallholders to adopt sustainable practices, and also more importantly, how do they get paid by switching to this sustainable practice and get compensated the correct way. Next, just list a few existing work. A member, our working group member, Martina, does soil management related agroeconomics work in Tanzania, and Irene has worked on crowdsourcing market information in the palm oil context in Indonesia, but a lot of the insights there can be carried over for the palm oil questions in West Africa as well. And then at the same time, I have some work collaborating with NGOs in Uganda, thinking about how do you do contract design to encourage more farmers to sustain tree growth and do agroforestry on their farms. The next topic is it is intertwined with the agriculture. So first, to talk about forest. We know that forest provides many ecosystem services, and this include carbon sequestration and robust biodiversity and restored ecosystem. However, we also know that the deforestation causes are interlinked with agriculture and energy consumption, because often smallholder farmers are using wood as wood fuel for cooking stoves. So one way to discourage deforestation is to implement a system called payment for ecosystem services. And we want to note a few successful projects done by NGOs in East Africa. One is called the Trees for Global Benefits project done in Uganda by the NGO called EcoTrust. And second is Trees for Hope in Malawi done by the William J. Clinton Foundation. So here the NGO or some private carbon buyers who wants to capture carbon or to do carbon offset projects will pay the landowners to not cut down trees over a period of time. So this way, both the NGO and the farmers are getting their benefits. Just to highlight one more project that we have in the working group, which is that I have some work on thinking about how do you design these PES payments so that they're simple to implement, but also create some efficiency without harming anyone's welfare, and in fact improving landowners' welfare. So there's a lot of opportunity for data science to help with forest management and deforestation space, because only with good monitoring through technology like remote sensing and satellite imagery, we can implement these market mechanisms more cheaply with minimizing the program cost and monitoring cost that's involved in the system. The third example we want to give is energy consumption and efficiency. As we have discussed in the previous slide, that approximately 90% of all wood removed from African forests are estimated to be used for wood fuel, and this is largely for home cooking. So the question we want to ask is, how do you promote how do you give everyone energy accessibility? And at the same time, we should be promoting solutions that are energy efficient and climate health friendly, because local air pollution harms the population's health greatly. And at the same time, we want to highlight that Farewa in our working group, she has been working on energy efficient cooking stove device as her PhD thesis project. At the same time, there's a lot of existing economics randomized control trials that's being done on thinking about how do you promote the most energy efficient and health friendly energy solutions. So in this space, we see there are two opportunities for data scientists to come in. One is thinking about off-grid energy planning, and then the second thing is thinking about doing more advanced data analysis to think about the causal reason for how do you switch between energy efficient solutions. Now we'll turn the slide to Lily to talk about wildlife conservation.
So the wildlife conservation problem is particularly stark in Africa, and let's look at the problem of African elephants as an example. So less than 100 years ago, there were over 10 million elephants throughout the continent, but today there are only about 415,000. So in the course of under 100 years, the population of elephants is just 4% of what it previously was. So we have drastic biodiversity loss. And if we want to preserve these critical species, and often keystone species within an ecosystem, we must take action today. So the biggest drivers of this wildlife loss are primarily habitat loss and also illegal wildlife poaching, where poachers will hunt creatures like elephants for their tusks to sell on the illegal black market. So an opportunity for data science is to predict poaching hotspots to help rangers plan patrols. So one of the biggest ways that we're able to help combat poaching is through ranger-conducted patrols. So rangers will walk through a protected area and then look for snares and traps that have been left behind by poachers to trap these precious animals. So for this work on preventing poaching, I have been working with the Uganda Wildlife Authority in 2 national parks in Uganda, which are Murchison Falls and Queen Elizabeth, shown on this map. And these parks are home to creatures like elephants and lions and Rothschild's giraffes, as shown in this picture. So what we're able to do in this context is leverage historical information about where rangers have gone and where they've found poaching, and then build machine learning models to predict, based on geographic features in this park, where we think poaching is most likely to happen in the future. And the challenge here, as highlighted at the beginning, is the problem of limited data and limited resources as well. So we only have data about certain areas of the park that have been patrolled a lot. So we're trying to extrapolate that to predict poaching patterns in other areas of the park that we have not seen as much, so that we can most strategically send our rangers out to remove these snares and save animals. So I have a paper on this if you'd like to read a little bit more about some of our work, and specifically the field tests that we have done in Murchison Falls.
Thank you, Lily. Thank you everyone for listening to our talk. And we're as a working group, we're actively looking to connect with more collaborators, data scientists, and NGOs to think about how we can get more projects done that are towards our mission. So you can go to our website to take a look at recent works we've been doing, and feel free to shoot any one of us an email. We look forward to hearing from you. Thank you.
Wonderful, thank you so much. I believe we still have Lily on this call. I don't see any questions in the chat, but we can take a few minutes to answer any questions that folks might have, or even comments. I know Shira, for instance, you've worked a lot in this space, so any thoughts that you would have, would love to hear it.
Yeah, thanks. It's always great to see work on biodiversity monitoring and, protecting the ecosystem. Yeah, right now I don't have no question comes to mind. Let's see what's on the chat.
That sounds great. Okay, we'll monitor the chat, and while we do that, we can play the next video, which is by Sam Taggart on global perspectives on inequality, which is a second working group that we wanted to highlight.
Hi there. My name is Sam Taggart. I'm an assistant professor of computer science at Oberlin College in the US. And I'm going to be talking to you about the mechanism designed for social good working group on inequality. Our group is interested in the sources of inequality and solutions to inequality, especially economic inequality. This is a broad topic with lots of dimensions. A couple of the questions that we've been especially interested in recently include, what goods and services should you provide to everyone? And what goods and services should you target specifically at the poor? And for those latter goods, how do you identify those with the most need? This is an especially important problem for things like poverty relief or microfinance, but also for things like health interventions, since poverty and negative health outcomes are quite correlated. And if you think hard about it, probably your favorite problem has an inequality dimension as well. For example, climate change will affect some people much more than it will affect others. Here are some of the members of our group. I've got 10 listed on the slide, but there are some more probably. Either I've forgotten because I'm silly or I just didn't have room. But this gives you a sense of who we are and where we're from. If you want to work on the problem of inequality, it's obviously helpful to know something about economics. But what makes our group special is that we also have members with backgrounds in artificial intelligence and machine learning, as well as optimization. What I want to do in this talk is focus on the problem of targeting, identifying the most needy for provision of benefits. I want to give you a sense of some of the basic solutions to that problem that people have approached, and some recent projects from members of our own group. I want to give you a sense of what the problems are in this space, the work we've done, and hopefully convince you that this isn't just a set of economic problems, but that there's also an interesting data science component as well. So here's the problem of targeting again. You wish to transfer goods, services, or cash to the people with the most need. How do you identify those individuals? If you have a robust tax system, this is quite easy. People report their income on their tax forms, so you can look at their income, pick out those with the lowest income, and provide your good or services to those people. When this problem is interesting is when you don't have access to tax data. Perhaps you're in a development setting where a large portion of people's income comes from the informal economy, or perhaps you're an NGO who just doesn't have access to the same data that the government has. In either case, you're faced with a real challenge of first finding data that will be meaningful for identifying those with the most need, and then interpreting that data in a useful way. What I want to give is two common approaches to solve this problem. The first approach is called proxy means testing. And the idea is you're going to do some statistics. You're going to train a simple statistical model to try and predict whether someone is poor or not. This is used in lots of cash transfer programs and programs in social safety nets of various countries, including in Africa. One example would be the Productive Social Safety Net program in Tanzania, as well as all over the rest of the world too. This is used in lots of cash transfer programs, for example, in Indonesia. A proxy means test has two stages. The first stage is the training stage, and the second is the application stage. In the training stage, you gather all of your data. And your data is going to come from a survey. So you ask lots of households sampled from your population, how much money do they spend on things? Those that spend very little money probably are poorer. And then you also ask for a lot of information about the rest of these people's lives, including some of their assets. Do they own a motorcycle? Do they own a refrigerator? As well as basic information about their households. How many children do they have? What's their house made out of? And then you're going to train a simple linear model, so essentially a line of best fit, to predict a household's consumption based on their assets and their household traits. You're going to get a simple linear formula for whether someone is poor or not, or rather a prediction of that fact. And one thing to note about these assets and household traits is that they're the sort of data that you could gather just by going to someone's house. because that's what happens in the application stage. Government enumerators go door to door and apply the formula based on what they see of a person's household and use that to determine whether someone is poor or not. That's the proxy means testing approach. This has a couple of challenges. You have to be able to send a survey out to everybody, and you have to be able to send enumerators out after that. So it's infrastructure intensive. Typically, these formulas aren't published to people, so it's an opaque process. And there's also some accuracy problems. On the right, you'll see a chart from a proxy means tested program in Indonesia, where on the horizontal axis is people's predicted consumption. On the vertical axis is their actual consumption. And you'll see that there's quite a few errors, both inclusion errors, so people receiving benefits who probably shouldn't have, as well as exclusion errors, people who were eligible but somehow didn't get any benefits. The second standard approach to targeting is community-based targeting. So instead of training a statistical model, you're going to utilize local knowledge, what people know about their neighbors. This is also used in lots of cash transfer programs. And because it's less infrastructure intensive than proxy means testing, it's also used for a lot of smaller scale health interventions. And the way it works is the following. The data collection step will involve going into a village or going into a part of a town possibly, and collecting a group of community members, maybe 5. And then you're going to ask this community member group, who is the poorest in your community? Or more specifically, you're going to have them rank the wealth of every single member of their community. And then the lowest ranked people are going to get the benefits because they are maybe the most poor. Of course, this also has problems. Prominent members of the community may exploit the process to get access to benefits. These rankings might not be as accurate as you would like. And in particular, the community members' ideas of poverty may be different from your own. So those are both problems with community-based targeting. But then when you're presented with the alternatives of community-based targeting or proxy means testing, you have an additional set of data science questions you have to answer. You have to understand, when is a proxy means test going to do better than community-based targeting? Or when is the community structure going to be good for the type of data that you're going to be gathering from the community-based targeting procedure? So those are 2 of the standard approaches to targeting. Hopefully you get a sense now of just how data intensive they really are. And if you find this to be interesting, I and another member of the inequality group gave a tutorial on this topic at the ACM Conference on Economics and Computation this year. This is a 2-hour-long tutorial, and all of the materials are publicly accessible. This includes slides as well as videos of the lecture. All you need to do is click the link on this slide or Google the conference. Okay, so those are the basics of the targeting problem. Now I want to show you 3 projects from members of the Inequality Working Group that ask fundamental questions about the problem of targeting. The first project, led by our group's Bedia de Bebe, asks the fundamental question of who should be receiving benefits in the first place? How do we define poverty? From what I've told you, the standard approach is to identify those with low income or possibly those who have the least money to spend, so they have the lowest consumption. But the fundamental observation of this paper is that there's another way of being vulnerable. So you can imagine someone with a moderate amount of income, but because of maybe a health condition or because maybe they work in agriculture and are subject to crop failures, they are possibly facing a higher amount of income or wealth volatility in the future than someone with low income who maybe lives in an urban area. And those individuals, their probability of being ruined, being rendered abjectly poor might actually be higher than these latter people with lower income. So a definition of poverty should include how volatile someone's wealth is. And in fact, the main observation of this project is when you incorporate shocks to people's income, this volatility, your priorities might reverse completely. The people that appeared well off when you were looking just at income might suddenly become very vulnerable. if you allow this to change how you target, there are a couple of questions that you immediately have to solve. There's the algorithmic question of who should you be providing benefits to now? You have a fixed pool of cash that you have to give out. How can you use knowledge of people's income shocks, their income volatility, to give the money out to the people who need it the most? But then there's also a really interesting statistical question here. Income volatility can come from a variety of sources. It can come from your health, it can come from your family, it can come from your occupation, such as agriculture. How do you learn who is the most vulnerable, whose income is the most volatile? This is a really important data science problem. On to the second project. This is led by our group's Sarah Lenardi. And it attacks the question of why do we allocate benefits to the people to whom we allocate benefits? So if you look broadly across provision programs, there are two types of errors you might see. There's exclusion errors, so poor people who are not getting benefits, or even poor people who don't even apply if there's an application process. And then leakage. So this is people who don't need the benefits who get them. If you look broadly across lots of social programs, you'll notice that type 1 error is much more common. We are much more afraid of leakage than we are of improper exclusion. And one common explanation is that we resent people who don't deserve benefits who get benefits. So a fundamental question here is, how do we decide who is deserving and who isn't? And that's a question that this paper answers in a specifically development context. So what they did is they went to a shopping center in India and asked people for donations to be given to poor people. And they told these donors about the people that they were giving money to. And they told them one of two things. Either the recipients were near a foreign-owned factory where they had an employment opportunity, or the recipients were not near such a factory. And the observation was that being near a foreign-owned factory made people less likely to give you money. So somehow proximity to foreign investment makes people view poor people as less deserving. The sorts of opportunities that come from globalization affect the politics of provision. This is a really important thing to think about. The last thing I want to tell you about is a project of myself, along with our groups Ready at Bebe and our student Christian Okokwu. And it asks the question of how do communities provide for their most vulnerable on their own? And we look at an arrangement that might be familiar to some of you. So this is sometimes called a rotating savings association or a rotating credit association. The way it works is you have a group of maybe 5 to 10 people who get together every month. And every month, every member contributes some amount of money to a common pot. And then one member receives all of the money in the pot. This is maybe decided at random or via some sort of bidding process. This can be useful for a couple of reasons. So if you don't have access to a bank, this is a way of saving money. If you get the pot later, the money you are putting in early is saved effectively. And this can also be a form of insurance, especially if you have a way of getting the pot earlier by buying it from someone or via bidding. So if you have some unexpected expense, this can be a way of paying for it. This is ongoing work. What we're asking is, how well do these arrangements do at getting the pot to the person who needs it the most? And this process of participation every month is a really rich one. It happens over time and it involves a lot of social interaction. So from both a theoretical and an empirical perspective, this is really challenging. The models have to be complicated, and the data that you would have to gather is going to be really rich data, and it's going to be very challenging to interpret. So this is ongoing work. Okay, so that gives you maybe a sense of the sort of problems that our working group is interested in within one subtopic. There's lots of other stuff we're interested in, and this might be where you come in. If you think you have a really interesting data set that you would love to see some work on, or maybe you've been working on something inequality related for a while, the inequality working group here might be a good place to get feedback. Here's my email in case you decide to reach out. Thanks.
Excellent. Thank you so much. Sam isn't here, but thank you for letting us play that. And I guess thank you to Sam. We'll let him know over email. I don't see any chats or I don't see any questions in the chats, but I'm happy to answer any questions that folks might have. If you want to jump in, so feel free to just jump in or chat your questions. And I do want to say also that both sets of organizers for the inequality group and the climate group have mentioned their email addresses, but you can also reach out to any of the organizers, myself or Irene or Anna or Francisco, whom you'll hear from shortly, if you have any questions about the initiative more generally. So with that, we'll conclude the first half of our presentation. We're going to move to the second half. And for this part, Francisco will be giving a presentation as well as also leading the discussion. Francisco, are you here?
Let's see.
Yes, here you are.
Can you hear me? Great.
Very good. Okay, so I'll let you take it from here.
Sounds good. So for the so first of all, I also want to say thank you to everyone in the first half of this, because this was really wonderful. And echoing what Rediet and Irene said at the beginning, we're really excited to be working with TSA. TSA is an organization we admire greatly, and we look forward to the conversation and discussion that comes at the end of these following talks. So without further ado, our next talk is, let me just pull up the, do we have slides that we're sharing for this?
Yes, you can share slides. So you're doing the development working group, right?
Yes. Oh, I thought Abeba. Oh, okay, great. Then I'll go first with mine then. Perfect. Let me just pull up my slides then.
Just confirming, you're trying to share your slides, right?
Yes, I'm just pulling up my slides. Apologies for the delay,
okay,
everyone.
No problem at all. No problem at all. Just confirming that there are no issues.
Okay. There we go. Can everyone see my slides?
Yes, we can see it.
Okay, great. Well, so thank you. My name is Francisco Marmolejo. I'm a research fellow at the University of Oxford. And over the past year and a half, I've been co-organizing the development working group. And I'll talk a little bit about the development working group, about some of the work that we do, and in particular delve into one specific project that we've been pushing for the past couple of months. So kind of echoing what Irene mentioned at the beginning, the core MD4SG mission is that of improving access of opportunity to historically underserved and disadvantaged communities. And one of the key assets of MD4SG and its participants is that we bring a fundamentally interdisciplinary approach to the table. And this, of course, on the technical side of things, means that we use techniques from algorithms, optimization, mechanism design, you name it. But at the same time, we have this multi-stakeholder approach where we bring in individuals who actually implement the objects that we study in practice, as well as the stakeholders whom we wish to help with our research initiatives. And so in line with this, we have the development working group works on issues that partake, that mostly have to do with the application of these technologies in emerging nations and under-resourced settings. And most importantly, I like to think of the development working group as being incredibly interdisciplinary. So we really bring together people from multiple different disciplines, people from that have to do with the actual practice of implementing these solutions in the developing context. And we bring these diverse sets of skills and backgrounds to inform policies and practices in this space. And so to give you an idea about the composition of the group and some of the activities that we partake in. So our members come from all over the world. We have a truly international representation in our group, and we have a very strong contingent from the African continent as well. And as mentioned before, this really helps us build a proper context of the problems that we are trying to tackle. And just as much as geographic diversity, we also have an academic diversity as well. We have individuals from computer science, from economics, statistics, management science, and we also have some strong collaborations with individuals from NGOs or other policy institutions that are actually implementing some of these solutions in practice. And I mentioned just some of the main activities that we partake in as a working group. Which is, with most working groups, we meet usually on a bi-weekly basis throughout the academic year, and to foster this work that we have invited talks or just internal conversations about some of the work that we're pushing forward as a group. And on the off weeks to these bi-weekly meetings, we really push for smaller projects that are specific research outputs of the development working group. And we have a handful of projects, but I mentioned just a couple right now, which may be of interest to the DSA community. The first is we've actually partnered over the past year with an agriculture information dissemination application called AgriPredict in Zambia. And one of the problems that we're aiming to tackle is the fact that supply chains in the agricultural sector in Zambia can be highly inefficient. As an example of this, you can see that there's a huge disparity in terms of the price that crops will get at final market values versus what farmers get at in the first place. And one of the projects that we're tackling with AgriPredict is trying to alleviate these inefficiencies in the agricultural supply chain with mechanism design. And again, this is an example of when we've had a successful partnership with an on-the-ground institution that is already affecting the stakeholders that we wish to study. And another project that we're working on in the development working group is that of the role of access to information in educational decisions. And this comes into play in the context of when potential students are making a decision in terms of, say, even which educational institution to attend, that information which they have access to, which is again governed by whatever network they may be in, whatever social situation they may be in, has potentially far-reaching impacts in terms of the decisions that they take. And we're trying to piece apart this information in the developing context. And finally, and what I'll be focusing on mostly in this talk is a recent project actually, relating with COVID-19 and the pandemic that's currently ongoing in the world. And what's interesting about this COVID-19 project is that it was really born actually over the past 4 months. The development working group has really been pushing for trying to piece apart what COVID-19 means in the developing context. And this is, it meant a slew of discussions, and mostly, and in fact, most of the discussions from our, that we had related to COVID-19 can actually be found on a Medium post where we've summarized a lot of the implications that the pandemic has for the developing world. And one of the projects that actually was born out of, that was informed out of this entire process is on how to optimize limited testing resources in low and middle income countries. And this is a project that began with colleagues here at the University of Oxford, but that was fundamentally informed by the development working group. And the ideas and the entire process was, it was very crucial to talk to everyone involved. And so without further ado, the project at hand is that of Test and Contain, which is a resource optimal testing strategy for COVID-19. And so we see multiple challenges with COVID-19, mainly that countries have been largely unprepared for the pandemic. And in a perfect world, we would be able to test everyone, and we'd be able to know perfectly who has the virus, who doesn't have the virus, and consequently, we'd be able to isolate those individuals and the virus would be gone. But in practice, resources are extremely limited. And this is a fundamental issue in low and middle income countries, especially. And resources can mean a multitude of things. It can mean anything from PPE to hospital beds to even the monetary compensation that governments give to alleviate the problems of the pandemic. But what we focus on is on testing capacity. And as an example, and I mentioned this example is Mexico, not just because I'm from Mexico, but also because we also have a working partnership with Mexican governments, which I'll talk about later. But to mention this issue, Mexico currently tests about 9,000 people daily, and there's a population of 126 million individuals. So this is roughly 7 people per 100,000. And so testing capacity is just extremely limited, and unfortunately, poor communities are hit disproportionately by testing shortages. And so there have been a multitude of resource-constrained responses that we've already seen, and perhaps the most impactful for our day-to-day lives is that of a lockdown. And many countries have seen lockdowns which have helped to alleviate the spread of the virus, but at a significant impact to local economy and well-being. In addition to lockdowns, there's also the strategy of tracking and tracing individuals to find out precisely where the virus is. And although this is very useful at tracing the virus, this has a very high complexity. It's labor intensive and it requires many resources. So this is not necessarily completely feasible in certain settings. And so what we posit is that there can be an innovative allocation and use of resources, namely the test kits, to balance multiple objectives. And what we're going to focus on is on limiting the spread of the virus and also minimizing the impact that the virus has on the economy and on social well-being of individuals. And these are competing objectives. And the fundamental building block that we use is that of group testing. And group testing is not a new technique, actually. So what group testing is namely you, rather than using a single kit or a single testing resource on one individual, what you do is you take multiple samples from multiple individuals, you mix them into one, and then you use that single resource on that mixed sample. And now this will be positive or negative. And if it's positive, it will tell you that somebody in the group has the sickness. And if it's negative, it means that nobody has a sickness, i.e. everyone is healthy. So in the illustration we have right here, the first group is red dots are infected, and the first group is entirely healthy. And so the group test will be negative. And in the second group, there are some individuals who are positive, so the group test will be positive. And so you don't know who will have the virus necessarily with a single group test, but you know that somebody does. And group tests are, well, the size of the group test is limited by the accuracy of tests. You can't have arbitrarily large group sizes. And so this is already, I mentioned before that group testing has been used in practice for different sicknesses. But in terms of COVID-19, it's something that's gaining a lot of traction and already being used in different geographies. And one of the most common procedures for group testing is actually what began the entire field, which is Dorfman's procedure from the 40s. Which it's very simple. Essentially, you take a population, you take disjoint groups, and you perform group tests on these disjoint groups, say of size 10. And now these are either positive or negative. If they're negative, they're all healthy, and you know that everybody's healthy. And if it's positive, what you do is somebody's sick, so you just test everybody in that group again, and ultimately you'll know everybody, whether they're sick or healthy in your given population. And for a population of size N and for the number of infected individuals being K, there's a formula for the optimal group size, and you can optimize for this two-stage strategy. But there are some issues with Dorfman's protocol, which, by the way, has already been used in practice in certain countries to high effect. In particular, Ghana has actually been very successful since February in implementing Dorfman testing to optimize testing procedures. And so some of the issues with Dorfman are that there are non-trivial logistics. There's this two-stage protocol where, depending on the first stage, you do something else. In the second stage, there are single-stage mechanisms, but they require much more tests than this. And ultimately, in practice, we still don't even have enough tests for Dorfman's procedure. Remember, I mentioned Mexico, there are 7 tests per 100,000. So this is far below the number of tests that Dorfman requires. And so one idea that we have to alleviate this is to look carefully at who we test. And this we ultimately have a heterogeneous population with different attributes, and we can allocate tests differently to different segments. So there are vulnerable segments of the population that are more affected by COVID. There are people who are likely to spread the virus. Perhaps we should allocate tests more to them so that they don't spread the virus. There are key workers who are necessary for society to function as is right now, and perhaps they need to be tested as well to make sure that these functions continue. And there is a large body of literature on these on these testing strategies with a heterogeneous population for individual tests. But again, we're looking at group testing, and again, if the number of tests is severely limited, then again, we can't do Dorfman. And so one of the other ideas that we actually look at is letting go of the idea of testing everybody at an individual level. So rather than enforcing that we need to know everybody's diagnosis exactly, we can use group testing to spread the reach of a certain limited number of tests, and we can have more population level information to help with containment strategies. And again, we lose individual level specificity, but we get population level benefits. And we can ask ourselves what group sizes are best. And so as an example, imagine that there's a village with 30 marketplace workers, and these marketplace workers meet many individuals. There's a single marketplace, so everybody in the village meets these marketplace workers. They're potential super spreaders. And 2 of these 30 marketplace workers are sick, and you don't know whom. So how should we test everyone with these 3 tests that we have? Should we test 3 workers individually and possibly miss out on a super spreader? Or should we test everyone in a single group test of size 30? In which case we would know that they're infected, but we would be isolating the entire segment because we would know better. We'd know, okay, somebody's sick, they must all stay, and we've created unnecessary social impact. Or, and in between would be to do 3 groups of size 10, in which case we would surely catch the individuals. One of the groups would be healthy, and we would still allow a certain number of marketplace workers to return to function at their role. And really, it's this intermediate strategy, which is what we're looking at in our work. And so our strategy, which we call test and contain, really balances these 2 objectives that I mentioned at the beginning, which is to limit the spread of the virus and minimize impact on economy and social well-being. And to do so, we decide who to test and how to test individuals. And I just mentioned some applications that this can be used, of course, to exit lockdown, but more so can actually be used to transit in between lockdown, as we might see certain spikes in the future, recurrences, etc. It's a very flexible approach. And it allows policymakers a proactive way of monitoring a second wave and balancing these objectives. And ultimately, it's actually applicable at multiple different population levels. Everything ranging from, a country level to even universities, schools, care homes, etc. When there's population level knowledge of individuals, we can use a strategy like what we propose. And so now let's get to the meat of the actual of the strategy. And so the assumption that we make, and that is key, is that every week there's a limited number of tests we can use. So there are t-tests that we can allocate, and we have a population that has certain categories, and these categories represent the heterogeneous nature of a population. So we have K categories, and what we're ultimately going to decide in our testing strategy is per category, we're going to decide 2 things. How many tests do we allocate to that category? And what is the size of the tests? What's the group size of the tests that we allocate to this category? And ultimately, given these 2 parameters, which here are TI and GI, we're going to perform these disjoint group tests on this category. And if a test comes back as positive, we're going to tell that segment of the population, well, this positive test, to self-isolate, because a testing policy must come hand in hand with a containment policy. And this is the overall approach that we take to testing and containment. And so one first flag, which must be coming up, is that of the categorization of the population. And so what are the key attributes that we need to focus on in terms of limiting the spread of the virus? So the first, of course, is the exposure to the virus that one might have. Which by exposure, I mean an individual being more susceptible to catch and to spread the virus, i.e. potential super spreaders. We can also look at the cost of containment. For example, a daily wage laborer who needs to put food on the table might have a higher personal cost of containment than, say, a software engineer who can work from home. And again, these are parameters that we can include in the model. But we can also look at geographical proximity to problematic areas or multiple other criteria. And I want to emphasize that we don't need very fine-grained information. Even rough data is already good enough to start making some benefits in terms of testing strategies. And this can be collected through symptom tracking apps as well. I mention this in particular because we're currently partnering actually with some states in Mexico, San Luis Potosí and Hidalgo, and they've given us access to some of their symptom tracking information, which we can see right here. So in San Luis Potosí, we have, this is kind of just an overview of all the people who have answered questionnaires, as well as kind of flags of risk that our partners have created with their app, Centinela de Salud. And in fact, their app even provides some interesting kind of risk profiles of different geographies of the capital, which can be some of the baseline parameters to say exposure to the virus that I mentioned before. And so going back to kind of the mathematical model, we assume that we had these K categories, and these categories have attributes. They have a certain size. They have we're looking at the probability of infection in that category, the exposure of individuals in that category, and the cost of containment that they have as well. And I mentioned this map because we can infer some of these from the symptom tracking app. And going back to the allocation and the group sizes in the strategy, there are some kind of rules of thumbs that are already kind of intuitively are a bit clear, which is namely that if we have a category where there's a high cost of containment, we might want to use smaller group sizes, because a larger group size means that somebody might be unnecessarily self-isolated. Think back to the 30 marketplace workers and a single giant group size. This is an unintended consequence of a giant group size. But at the same time, if we have a category with very high exposure, so that they are potential super spreaders, we might want to allocate more tests to that category to make sure that we catch the super spreaders. So we really are kind of balancing all of these things at once. And we formulate this in terms of a specific optimization problem, where the first half of the objective, which is minimizing the spread of the virus, can be represented by this formula, which essentially quantifies the expected number of individuals that are infected given the current testing regime. So those that are not caught that spread the virus. And then there's a second half of the objective function, which is looking at the expected number of individuals who are unnecessarily self-isolating, weighted, of course, by their cost of self-isolation. And really the amalgamation of these two things, we can take a convex combination of these two objectives, and we can optimize for this. And of course, we have certain constraints, which is that we have a testing budget. Our group sizes cannot be so large that they, because of the specificity issue that I mentioned before, we cannot waste tests. Our tests don't overlap, and we don't have fractional values in our parameters for the testing strategy. And so we have this is our glorious optimization problem, which is, it has a non-convex objective function, but but if we set the parameters for the group sizes, we actually get an integer linear program. And a first pass at this, what we've looked at is, and again, this is still a work in progress, but is that if we fix these, we can solve the integer linear program efficiently, and we can optimize this feasibly for small number of categories and group sizes. But of course, there's still potential for improving this because the objective is separable, and it's still fairly nice, and it's one thing that we're working on currently. And to kind of mention, so that was all great in terms of the optimization problem, but we also ran some simulations to validate, theoretically at least, what the results might be of running a strategy like this. And what we did is we implemented a graph-based susceptible, infected, recovered SIR model on a heterogeneous population. And we chose the parameters of the graph-based model to represent kind of a heterogeneous population. And the exposure of an individual is identified with a degree of that node. And you can think about this as the graph being a social graph. And for the simulation, so we generated a random network with a population of 10,000 individuals, where 9,500 individuals in the population are general population. But the other 500 individuals have different attributes. Namely, there are 480 marketplace workers with a high exposure, namely they could pass on the virus. and with a medium cost of self-isolation. And there are 20 key healthcare workers who meet many individuals, have a high cost of self-isolation because they're essential to the response to the virus. And ultimately, we run this model for 200 days, assuming a testing budget of 1 test per day. So a severely limited testing budget. And so here are some of the results of the simulations. On the left, we have the percentage of the population that is infected. And we compared the methodology to what's currently the practice, which is namely that if an individual is exhibiting symptoms, they get a test, which is basically choosing a random person who is infected, finding out that they're infected and isolating them. And as you can see, our mechanism has, which is on the left-hand side is the lower of the lines, has a reduction in the peak of people who are infected for the virus. And on the right-hand side, we actually look at the breakdown of those who have been isolated. And the key thing to notice here is that, well, first of all, there are less individuals in isolation in the methodology that we propose. And not just that, the breakdown of those that are isolated is important. The blue line here are those that are healthcare workers that are isolated. And there's a massive reduction in terms of the healthcare workers that are isolated, given the targeted approach of making sure that they have smaller group sizes in the optimization problem. And so just some outlook with respect to the specific project is we're looking to fine tune the population segmentation. And again, we mentioned the symptom tracking app, but there's much work yet to be done to choose the correct parameters in practice. Ultimately, we need to collect the information, if it's with the symptom tracking app or not. And there are issues of incentive compatibility as well. I mean, ultimately, the answers to the questionnaire will decide in an indirect way whether you get tested or not and you return to work or not. So there are incentives to be taken into account. And also privacy preserving. The privacy conserving data is also important because this is sensitive information as well. We also want to incorporate citizen compliance into models. We have seen that this is a really big issue around the world, is kind of citizen behavior with respect to COVID, and modeling this is essential for any practice going forward. Also, a key component that we want to take into account is the accuracy of tests as well. Testing isn't perfect. There are mistakes that are made across the entire pipeline. And so this is a fundamental thing to take into account when allocating these tests. And as group sizes decrease, this also has an impact, and ultimately this can all be incorporated in the optimization problem. We also have some interesting research directions in terms of a Bayesian analysis of group testing, because testing for COVID is not binary, actually. You don't get infected, not infected. You essentially get told something akin to the viral load, how much of the virus you have. And so when you perform group testing, there is potential to use this wider range of information in the diagnostic to actually get better information than just somebody's infected or not. And this can be very useful actually in the search for healthier infected individuals. And I mentioned also that we really want to push for these ideas and adapt them in the African context and for the African continent. And this is something actually that I'm really looking forward to talking to more people here at DSA for, because there is huge potential to use some of these same techniques here, and there's much that we can learn from all of you with your experience in building solutions from the ground up. So please get in touch if you would like to talk more about this. And ultimately, I mentioned that we'd like to have implementations ready for deployment because there is a serious possibility of a second wave. And in San Luis Potosí in particular, they're very worried about this being confounded with flu season, with dengue as well, and multiple other diseases that actually spread later on in the year. So there is a big push for trying to get something more optimized for that possibility. Thank you. So that's it for the presentation on the development working group and the group testing. I leave the floor open to discussion, or actually just checking with Reddit. Maybe since we were first, should I probably go towards Abeba's and George's presentation?
Yeah, maybe we can take questions. I don't see any yet, but maybe I can ask you one about, in general, in mechanism design, how I'm remembering the initial presentation where they were talking about working conservation areas and solving this problem of low data. So in general, how easy or how do you incorporate uncertainty in the whole in this whole mechanism design?
Thank you. That's actually a very wonderful and a very important question too, because without the proper model, uncertainty can actually make a mechanism go completely awry. And maybe I can go first with talking about the mechanism we propose for group testing, but then I can leave the floor open to others to opine on more generally. But in this case, the noise in terms of the data that comes in can come in two factors. I mentioned before that people can be strategic in terms of the information that they report to the mechanism, which can give rise to false information per se. So one way around this would be to have more robust categories that kind of pool together more people and kind of leave less information on the fringes in between categories. But that's immediately one way that I see kind of mitigating this in the group testing context.
Great, thanks. There was a question from a participant who was asking for some mentorship. I believe maybe you've seen it. Hallelujah was saying they're currently working on using security games to curb insurgency in Nigeria. They're looking for mentors. So I guess maybe you can point them in the right direction.
Definitely, actually. So if they're looking for, if they're studying security games, I mean, the first thing that comes to mind is, I believe Lily is working on security games with, actually this was mentioned in the talk, for wildlife conservation. And that entire group actually, which is now at Harvard with Milan Tambe, has lots of wonderful work on using security games. I'd be more than, I mean, first of all, I think be more than glad to kind of put people in touch, but definitely be glad to talk offline too about some of this work and some maybe possibly related literature with this.
Right. I'm just looking for more input from the chat. I don't want to hog all the questions, but I had one about what you talked about working in supply chain, I believe, and about how the income is spread between farmers and people further up the chain. I wonder if there's any work on what would be the ideal spread of income, because from where I sit, there's like division of labor. Somebody's in charge of growing the crop, but getting the crop to market also requires some skill. So when you're looking at such problems, what's being aimed for? Because I believe there's a whole spread of people who could be employed in the food production chain.
Well, definitely. I mean, that's a really important question that I don't think actually we have the correct answer to. You're right that I mean, ultimately, as the goods go from one point to the other, there are these middlemen that are providing a service and need to get compensated for the service as well. So, I mean, ultimately, the right level of compensation that we're pushing for is at least in the Zambian context, is to have less middlemen and to simply have a higher proportion of the ultimate price at which the crop is sold to be shared with the farmer. How much this will be decided at ideally can hopefully be decided by some sort of market intervention, but I don't necessarily have an answer to what proportion of this should be, other than higher than what it currently is, and more equitable and so that income for farmers isn't necessarily as disparate and volatile as it can be. And we hope to use some digital solutions to alleviate this. And I mentioned particularly that we're trying to come up with essentially digital solutions to lower the barrier of entry for middlemen, so that there can be more competition amongst middlemen. So to kind of to give a more nuanced answer to what you're mentioning, is that one of the problems that we see is that often people in agriculture don't necessarily have much of a choice, given their constraints of whom they sell to in terms of the middlemen. And so the market for middlemen is is very thin, and ultimately we're trying to incentivize more individuals to partake in transportation, to give to provide more competition for the service that they provide, and ultimately provide better better costs for farmers. By how much, I don't know, but definitely something that we're pushing for.
There's a question from Francis. I think, do you want to ask a question directly?
Hello, Mama Rejo. I just wanted to find, because I think you're doing an optimization problem, especially for the COVID problem.
Yes, correct.
What sort of algorithms are you using? Because I think I missed that part. Sorry.
So the algorithm that we're currently using, and there's definitely room for much improvement. So definitely, I mean, if you have any ideas and would like to help out, we're more than glad to kind of talk more. But it's a non-convex optimization problem, but if you fix one of the parameters, which is namely the group sizes per category, you actually get an integer linear program. And so for this, we just kind of throw it to an ILP solver, and it works well in practice. But the convex objective is actually, even though it's non-convex, the objective, sorry, I think I mentioned convex earlier, that it's still very nice. It's got nice separable properties. So there are potential for efficient approximation. It's something that we haven't implemented yet. By kind of judiciously partitioning the domain of the optimization, but again, if you have any ideas, we'd be more than glad to hear and to kind of further tweak the algorithms that we actually use.
Okay. Oh no. Thanks for the answer, because I think that is sort of similar to what they use, for example, for reliability prediction. And optimization for spare parts, sort of in reliability. So I was just thinking if that might also work as well,
Yeah, I mean, I'd be more than, if you could send me some more information on this afterwards, I'd be glad to kind of talk.
Yeah, I did shoot you an email. Maybe let me send you again. I think I was using my UCT address, but I think I'll write to you again and see if we can work on something. Okay, thank you.
Amazing. Thanks so much, Francis.
All right.
We have similar names. In Mexico, we'd be called tocayos.
Okay, so I guess I'll leave it over to you to Enredia to continue with the program.
Great. So I guess I'll stop sharing for now then. Just give me a sec. So I believe then that our next presentation then is from let me just check. Okay, the order is from the data economies group. Let's see. So so just to introduce the data economies group. So the data economies working group is a vibrant group of researchers, and they have multiple ongoing projects. I'm sure they'll talk about it more right now during their presentation, but here to talk about the data economies working group, I guess, oh, there we have this. We have Abeba And we're going to have Abeba and George talk to us about their wonderful work. There we go. I think I see you guys. Let me just pass the mic on to you then.
Thank you. Thanks very much. We are very excited to be here. It's also fascinating listening to everybody's presentation. So let me see if I can share my slides. I have host disabled participant screen sharing. Sorry, is there a way I can get around to this problem?
Let's see. So for participant sharing.
Yes, fixed. You can share.
Okay, thank you. Yeah. Great. So can everybody see my slides?
Yes.
Yeah, great.
Yes.
Yep.
Yeah, so yeah, we are the Data Economists Working Group within MD4SG. So today, myself and George will tell you about a couple of our ongoing projects. So for the Data Economists Working Group, these are members of our team. We have various backgrounds in terms of academic backgrounds, but also personally, we also have a diverse background. Most of us have associations to the African continent in one way or another. Some of us are based there. For example, George, who will be speaking right after me. Some of us are, even though we are studying abroad, we come from there, and some of us have worked within the continent in some capacity. So one of the, oh, damn it. Okay. So one of our ongoing projects is on data sharing in and for Africa. So there is a growing craze globally. There is a movement to make data open, if not completely open, to make data shareable, to share data, to make data accessible to other researchers or other parties. Also, data sharing is generally regarded as a hallmark of good science. It reflects transparency, it improves knowledge. If you share your data, other scientists can build on what you have done already, it, in general, also data sharing infrastructure and capacity of a nation also go hand in hand with development of a nation. So the case is clear that data sharing is and opening up data, which are kind of different things. While data sharing involves sharing your data with other researchers or government bodies, whereas open data is completely opening it up for anybody. So there is a great momentum to encourage data sharing. So there are so many positive cases being made for making data shareable and making data accessible. So one of our current projects is looking around that. So even though there is so much enthusiasm and great excitement about data sharing, we look at does this enthusiasm and does this positive outlook toward data sharing, how does that fare for African researchers, especially people who collect data and data subjects? So we look at, we delve deeper into the intricate and complex matter of what data sharing entails, if it actually is a net benefit for everybody involved. I hope my slides are moving. So yeah, so we take we zoom out and we take a broader look at who is involved in data sharing. So for example, here is a brief sketch of the stakeholders in the data sharing ecology. So you have data subjects where the data comes from, where data is often extracted from. You have data collectors. These are people that work on the ground at the very low level. This can be people who collect census data or that kind of data. You have machine learning or AI researchers who have invested interest in data sharing because any work in building any machine learning system heavily leans on a huge amount of data. And also policymakers, they have invested interest, funders and NGOs. This is especially important in the case of in the case of the African continent, because a lot of the data sharing initiative comes from NGOs and funders that fund research projects within Africa. They often demand the data be shared or made open. So they have a heavy stake in the data sharing ecology, but also big tech and governments also hold part. So when we are talking about data sharing, the machine learning researchers or the policymakers or the funders, those are the bodies that often take the center stage, whereas the data collectors and the data subjects, even though they are the most crucial elements in the data sharing ecology, their interests and their welfare and their benefits are often kind of ignored or sidelined. So in our current project, we specifically focus on what it entails for the data collectors and for the data subjects, and what it means for them, what data sharing means for them, and whether they benefit or whether it's a net good for them. So in doing that, we take a very humanistic approach. We lean a lot on disciplines and schools of thought from decolonial studies, critical race studies, feminist studies, those kind of lenses. So it's not just, is data sharing good? We get at the questions of is data sharing good for who? So who benefits from data sharing? And who is being exploited by their data being shared? And what kind of data is also being shared? So does the data contain sensitive personal information that should perhaps not be shared because it might impact, if it's unidentifiable, will that have impact on the data subjects themselves, but also who has access? And we believe that data are somewhat some form of telling a story. So through data, through your analysis, you are telling a certain kind of narrative. So whoever has the data is the person telling the story. So who is telling the story? But most importantly, what are the economic returns to communities, especially the data subjects where data is extracted from? So we approach data sharing from these lenses. So those are within the specific, we have a current working paper on data sharing for Africa. Those are the kind of the specific lenses we approach data sharing from. But generally, we, through our working group and also through our papers, we try to kind of push against stereotypes and cliches about the continent. Some of them you have, for example, it's very common to see headlines, for example, like the AI invasion is coming to Africa and it's a good thing. You know, this kind of unrealistic image where data and AI is seen as the only thing that's lacking, and if we have that, all Africa's problems will be solved. Yes, we do believe data is an important part of the solution, but it's not the only solution either. So we try to push against that. You also have something like, you know, can AI leapfrog the continent into development? It's almost seen as a magic wand. But also within the data sharing narrative, you have stereotypes such as lack of data sharing, or problems that arise with data sharing come from backwardness of the people, or because they are uneducated, that kind of stuff we try to push against. Also deficit narratives. This is where the narrative revolves around you know, problems or deficits or limitations of a continent. So you see research on poverty, or you see so much on diseases or starvation, that kind of narrative where the focus is the problem of the continent rather than highlighting you know, the positive aspects that the continent can offer, such as music, medicine, cultural aspects, or some of the most amazing research that's happening within the continent, or even the fact, even portraying the people of the continent in as agents in themselves. So we also try to push against those problems. So in our current working paper, as we investigate the challenges that are present in the way of data sharing, we deploy a methodology of storytelling. So what we do is we interview people that work with data that are either based in the continent or that have relations to the continent. So yeah, that are linked to the continent somehow. We interview them and we transcribe those, and we change them into personas, into stories, in order to kind of get at various issues such as economic inequality, colonialism, or asymmetrical power dynamics. So we chose storytelling because we can anonymize the names, and we kind of that way we can replace sensitive data such as you know, even a country or a name of an organization, or the person that's the data collector herself or himself, and we can protect sensitive information, but also by engaging with African or African related researchers, we also get the perspective of the African. So one of the core tenets of the humanistic approach is to put the human at the center, and to place the you know, the individual or the community that is the most disadvantaged, and to approach problems from their lens. So it's fitting that our methodologies also revolve around African stories and African researchers, and also storytelling, which has deep roots in oral traditions in Africa. So as I said before, storytelling is powerful, and data, narrating stories or collecting data or presenting your analysis and your findings are a way of telling a story, and we want to tell stories from the African perspective. So here is an example of one of our personas. So in this case, you have everything is anonymized and it's been given a different name. So you have, in this case, you have a European NGO going into a small country in Africa, and they want to provide a sustainable water and health service. And they want to improve access to portable water. So in order to do that, they want to assess the ground truth first. So they collect data on about the habits, the water habits of the community. So, but through the narrative, what you find is the NGO didn't follow local norms. They went into with their own questions. There was no attempt to kind of adapt that into what's important for the local community. But also after the project was finished and the NGO left the community, there was no attempt to there was no long-term planning as to where the data will be stored and how the data will be looked after. So you find various issues through this narrative. You get at the core of, you pick up issues such as a discard for local norms. You see that a lot of what the NGO is doing is from their own perspective. So in a way, even though the claim is to provide access to portable water, everything is done in a way that benefits themselves. And you also see lack of regulation in the process as well. Again, coming back to one of the current working papers, when you look at data sharing problems, why data sharing is not taking off, especially for the African researchers, you find so many issues, so many points. Some of them are infrastructure or lack thereof. There is no sustainable or good infrastructure that allows data sharing. The other problem is funding. And the other main one is trust. So trust at so many levels. So trust at one level where the data, the people where the data subjects simply don't trust the data collector. So they either give incorrect data or they are reluctant to provide data. But trust at another level where even after the data is collected, the data collector is reluctant to share their data with other researchers or government agencies because there is lack of trust in the dynamic. And this is not unfounded. You find so many reasons for this. So, for example, you have research parachuting or data parachuting, where when people, especially data collectors in the case of African researchers, when they make their data accessible, when they share their data, what you find is you have researchers from the global north who have much more access to infrastructure, much more access to publication. So they take the data from the data collectors, the African data collectors, and they publish research findings in often in the global north with either very little acknowledgement to the data collector or the African communities where the data is coming from. This phenomena is known as research parachuting. So all these lead to trust being as one of the main issues where data sharing is not as common. Also, awareness or lack of awareness, where people are not entirely aware in the consequences of providing data and how that might be used. Also, data regulations or lack thereof is one of the major issues within the African continent. Power imbalances, this is historical and current from the very down. If you look at people that collect census data, for example, from the data collector to the data subject, there is some kind of power imbalance where the data collector is in somewhat higher, it has somewhat higher bargaining power. When you look up again, when you look at the NGOs that might have ordered data collection and the data collector, there is another power imbalance where the NGOs demand or they dictate the norms and what data is being collected. So there is power imbalance all the way through, and also data colonialism. So data colonialism can be very nuanced. It's not like traditional colonialism where the colonizer comes and rules with brute force, but rather this is where the case where you know, the research interests of the researchers from the global north or people with higher bargaining power dictate what kind of data shall be collected and who is going to be the data subject and who is going to be included and what kind of ideas are going to be investigated and what ideas are going to be left out. So all these dynamics kind of have that inherited colonialism within them when you look deeper. So these are all challenges that get in the way of ethical and kind of responsible data sharing. And in our current working paper, we look at trust, power imbalances, and data colonialism. So overall, what we aspire for is not just to blindly support and advocate data sharing, especially the craze for data sharing and all these initiatives for data sharing and opening data in the north do not exactly translate for the African continent. So we want to support, we are behind data sharing. We also acknowledge the benefits of data sharing, but we want to approach the question of data sharing in a way that centers the benefit, the welfare and the interests of data subjects and data collectors in a way that puts their interest at the center. Yeah, that's what we hope for. If I will hand you over to George in a second, but if you work, if you are a data collector or if you work within the kind of data practices that I've been describing, and if you would like to get in touch, my email address is here, or you can email any of us that are part of this team. Yeah, so if you have any insights, if there are issues that you think are challenges that we haven't covered, we will be more than happy. We'll be very happy to hear from you. And now I will hand you over to George.
Thank you, Aviva. So given the numerous challenges of data sharing, our group, composed of researchers and developers, have simply developed a data prototype platform. So these are our members. Simply our members are, two of us are based in the African continent, especially Kehinde and I, and we also have researchers as well as developers spread across different continents. Next slide, please. Now, the plan is we've more or less developed a data prototype platform. The idea is the platform should be able to host and categorize data sets in a way that intends to make data available and as well as usable to a much broader audience. And the goal is to share data for research purposes and also to empower communities where data is being shared, especially on our above work. So basically, the goal is to add a recommendation feature using different recommendation algorithms to account for the type of data, the geography, the domain, and as well as other relevant information. And in future, we plan to run a user study to more or less improve the usability and as well as the practicability of our platform. And once our platform is in a production state, we'll of course solicit support from DSA and its members, and as well as researchers who intend to share the data, for the wider community. If you want to reach us, if you want to reach me, that's my email. And if you want to reach other members of this group, you can as well reach us. Thank you so much. My presentation is basically short.
Great. Well, thank you, Abepa and George, for your presentations. Unfortunately, we're running a bit late, so we might have to take some of the questions offline. I just wanted to kind of just to give some closing remarks on our work with MD4SG and possible for future collaborations. So can everybody see my screen?
Yeah.
So just to kind of tie back to kind of overall the umbrella of MD4SG, we mentioned that our core mission is improving access to historically underdeserved communities, and that we take this interdisciplinary approach, which has been exemplified by all of our working groups and the wonderful work that everybody is doing. And so thinking forward, there really are multiple ways that we can all work together and to achieve this goal that we have at MD4SG and that DSA definitely pushes for as well. So going back to what Irene was mentioning at the beginning, there are multiple key key activities that MD4SG partakes in. The first, of course, is our colloquium speakers. We'd love to have more participation from individuals from within DSA, or possibly even speakers that DSA might have. We'd love to hear more in the future on how we can work forward with this. But I mean, as we've seen, we have these working groups that work in many different areas of interest, of possible interest to individuals within DSA. So, and as you can see, DSA we know is wonderful at tackling problems from the bottom up and actually getting some of these implementations off the ground. And we're very excited for the possibility of having all of you help us out with these goals. And please feel free to get in touch with us. If you would like to even join one of these working groups, please feel free to get in touch with us. Even if you would like to start a working group as well. I mean, it's not limited to just these groups that we have right now. If you think that you have an area of research that is of interest to this broader interdisciplinary community, we'd love to hear and to talk to all of you about this and try to get something off the ground. And at MD4SG, we also have multiple partnerships with different non-academic institutions. And so if you, for example, represent a non-academic institution and would like to, again, try to have some specific problems that we can all work on together, we'd love to hear from you as well. And finally, I'd like to mention the workshop activity side of what MD4SG does, because we have a workshop coming up very, very soon. We have our 4th annual workshop on mechanism design for social good, which will take place virtually at the end of August. And our focus is on bridging research and policy. And here's a link with more details, but really we'd love to see you there. We really, and just to end, we really have so much respect for the community at DSA, for all the wonderful work that is being done here. And we would love to learn more from your experiences to tackle the specific issues that are important to all of us here. There's much that we can learn as well. And we really look forward to hearing from all of you and to working to improve access in the future. Thank you so much for having us. And feel free to get in touch with any of us if you have any further questions, but thank you again.
Yeah, thank you very much for that tour de force of, I didn't think it has flown really the time, and we appreciate the talks. Unfortunately, not enough time for interaction. That's always the risk we run. But I hope people will be able to engage on the chat. If the panelists will be able to stay on a bit, there may be some people who have some questions for them. Yeah, so thank you very much. I think now we'll have to change gears. We'll be talking about visualization of high dimensional data. You're more than welcome to stay on for that. There may be some synergy there with mechanism design, I don't know. So I guess the participants may want 1 or 2 minutes to stretch and change mental gear.
Yeah, that's fine.
Yeah, I mean, yeah, so I'll maybe just 1 or 2 minutes for you to stretch, and then as Philip gets ready with his presentation and puts it on. And of course, in those 2 minutes, if you want to engage with Abeba or Rabeshi or George, who had the last presentation, I guess you can engage on the chat. Thank you.
So currently I'm not allowed to screen share.
Martin, can you allow Philip to share his screen?
Oh, great, okay, now it works. Awesome.
Sarah, I think someone has put up their hand. Maybe they needed to speak as we stretch.
Yeah, you're free to speak or ask a question. Aksam Luanga, if you wanted to talk, your hand is raised. Okay. Yeah, so I guess everybody has stretched. As soon as you're good to go, Philip, can start.
Okay, awesome. Yeah, my name is Philipp Berens from the University of Tübingen in Germany. I'm really happy to be here today. Well, where being here means, of course, being with you online. I would have loved to be there in person, but as for all teaching that I also did during our summer term, of course, that wasn't possible. So I guess today we will go back, or now after this presentation by MD4SG, we will go back to a more classical teaching style, and during the first, I don't know, I think 45 minutes or so, I will give you an introduction to visualizations of high-dimensional data with, in particular, tSNE. So the focus will be on tSNE here. And then I think after a lunch break, we will also have the opportunity to go through a tutorial-style practical where you can explore a bit the methods that I will present on some actual data. If you have any questions, so I'm not sure how you did it so far, I would just suggest you interrupt by typing something into the chat, and then I'm happy to discuss your question kind of as they come. And if we feel that it gets too close to the end of the hour, then we can still kind of move to a different format, but in principle, I would be happy to answer any questions as soon as they arise. Does that work for everybody? All right. So the work that I'm presenting here, or the material that I'm presenting here is really joint work with my postdoc, Dimitri Kobak, who did much of the research that lies kind of at the foundation of this. So I really would like to acknowledge his contribution to this as well. So let's see. Okay. So first, I would like to motivate what tSNE is and where we would use it in practice or what it's good for. And so here's an illustration of the goal. So often in many scientific disciplines, but also more widespread across different societal problems, you have data that comes in this kind of tabular form, like illustrated here. So we have many samples, often many thousands of samples, and several features that describe these samples. And because there's many features, it's very hard to visualize this data in a form that is intuitively comprehensible for us. If we have, let's say, a data set with people and we just have their height and their weight, then we can just make a scatter plot and look at the structure in the data. But if we in addition have 20 other features, such as their body mass index, their blood pressure, and you know, whatever, then it gets hard to visualize this data in a way that we can do some exploratory analysis and understand the structure in the data. So one subfield of machine learning research has been occupied with the search for algorithms that allow us to embed such high-dimensional data in low dimensions in a way that still allows for intuitive reasoning. So we would like to take this high-dimensional data set, this high-dimensional table, and somehow project it onto 2 dimensions in a way that allows us to reason about the structure in the data. So one in machine learning very famous data set is the so-called MNIST data set. It's in a way it's a very boring data set because it's just numbers. So MNIST corresponds to letters written on to numbers written on letters from the US Postal Service. And you can see all the zeros, they look slightly different, all the ones look slightly different, all the twos look slightly different, and so on. So why is this high-dimensional data? It's high-dimensional data because such a zero is an image, and I guess during also during your computer vision lectures, you already recognize that such image data can be represented in a way such as that is shown here, where you know, each image is one row, and where the gray level value of each pixel is an individual feature in the data. So our data matrix for MNIST would maybe look like all the different zeros being one row in this table, and then after all the zeros are done, one row for each one, and so on and so forth. And then we would like, from this data table, we would like to compute some low-dimensional representation, ideally 2-dimensional, that we can then visualize and plot. Now, there's an algorithm called PCA, called Principal Component Analysis. And the idea behind Principal Component Analysis is to take this high-dimensional data and compute one or two or several directions that capture the maximum amount of variance. So you can see that written here in a mathematical form. And what is mathematically equivalent, to find the direction that leads to a minimal reconstruction error. So W here is the direction. I have to very briefly change something with this pointer. Somehow that's not working really well for me. Can you still, I hope you can still see my pointer now. Okay, so we find the direction capturing maximum variance here, some W, or equivalently a direction leading to the minimal reconstruction error. So you can show that these two problems here, solving these two problems, that is equivalent. Instead of going through the math, we will just look at this animation here to the right to show you what PCA does. So PCA, we apply PCA to these blue points. They are already in 2D. And we would like to find a one-dimensional representation of these 2 points. This is this black line that captures the maximum amount of variance. So we would like, so what this formula is saying, right? We would like to find the W such that when you project the data on the W, when you compute the dot product and take the square, that that this sum here is maximized. So what does this correspond to? Well, we go by rotating this line around the center point here, we go through all the possible directions. You can see that the spread of the data, the spread of the red points when projected onto the black line, that this changes a lot with the direction that the black line is currently oriented in. So like this, it's really kind of the minimal variance along the black line. And if we wait a moment, not surprisingly, so this is kind of the direction where the spread of the points on the black line is maximized. Now, how does this correspond, or how can we show with this illustration that this corresponds to finding the direction that leads to the minimal reconstruction error? This is also, I think, quite straightforward to see. Basically, what you have to look at is what is the total length of the red arrows. These red lines, they connect the projected point to the original point. So they are the reconstruction error that you would make by ignoring that perpendicular to the line, and these are the reconstruction errors that you would make by projecting the data down and then trying to guess what the original value was. And these are clearly maximal like this and minimal again when the line points in this direction. So this is PCA. PCA is a very useful tool, and I think in any analysis of when you try to explore high dimensional data, it should really be the first method that you apply to the data and first thing to look at, because it's very clear, the mathematical properties of PCA are really well understood, and it's really clear what's happening. Now, what happens when we apply PCA to our MNIST dataset? Then you get, so we take this high dimensional dataset in our tabular form, we apply PCA, so we find in this high dimensional space, we find the direction that captures the maximum amount of variance, the 2 directions that captures the maximum amount of variance, and then we project each of these images onto these 2 directions and plot them in a scatter plot here. You can basically see one big blob. In the different colors, we colored the different numbers. And, so the zeros are back here. The ones are here. And then I think the 3s are this green blob in the middle, and so on. So there's some structure that is captured by that. Maybe, you know, this first principal component here could be something like blobbiness or stripiness, but it's not a very helpful visualization in the sense that it doesn't show us the different numbers in kind of discrete clusters or something like this. So it's hard to learn much from that. And in fact, when you go to higher principal components, you can see more structure. But then again, it's not 2-dimensional, so for us, not easy to reason about. So this is where a method called t-distributed nearest neighbor embedding, or tSNE, comes in. When you apply tSNE, so I'm kind of taking a peek already at the result. When you apply tSNE to MNIST, what you get is something like this. So again, the colors correspond to the different numbers. My cursor is gone. So with ones being here again and zeros being back here, and then all the other different numbers kind of in the middle. What is quite a strong contrast to what I showed you on the slide before is that not only is there some kind of ordering along these axes, but colors with similar numbers, so 1, 2, 8, 3, and so, more or less form discrete islands in this representation. And now you can start thinking about, you know, why are certain islands next to each other, and you can start to reason about it. The problem about tSNE is that it's much more difficult to understand what is actually going on and what is determining the precise layout of the resulting visualizations, and what inferences can be made by looking at these visualizations. And this is what I would like to give you a brief primer on in the next couple of minutes or next half an hour or so. Before I do that, I would like to motivate you in learning about tSNE, because tSNE is really a method that is by now universally applied through many scientific disciplines and to really many data visualization problems. So for example, there's single cell transcriptomics or genetics more generally, where one tries to understand different cell types and their relationships. And here, for example, this is a paper from last year where they sequenced the genetic profile of more than 2 million cells, and you can make even for such huge data sets, there are now efficient methods to make such pretty visualizations. There's also other scientific problems, like for example, single cell and low mass cytometry, where you have really huge data sets also with several 100,000 data points. But maybe more interestingly, it can also be applied beyond biology. So traditionally, it has a strong background in biology. So biologists like to apply this method. But here, for example, it was used in physics, in astronomy, where each of the data points here corresponds to the light spectrum of a star somewhere in the sky. And then you can visualize all these stars and classify the different galaxies and so on, also depending on the structures you see here in these dimensional embeddings. I'm no physicist, so I don't understand the details, but I think it's still a fascinating applications of the method. There's also people who apply this in physiology or in behavior, in studies of behavior. So here they looked at the song dynamics of zebra finch, so bird song, and looked at how syllables of these songs, so these are spectrograms, looking at different syllables in these songs, how they are embedded, how the learning takes place over time in these for these syllables. When you just stare at these spectrograms of the syllables, it's very hard to understand something intuitively about them. But when you discover, for example, that during learning, a particular individual moves through these landscapes in a certain way, then this may be helpful for getting an understanding of what is happening. And finally, you can also apply it in the humanities. So here, tSNE was used to create a giant visualization of all the books in, I think, one of the largest digitized libraries. And I think this is a particularly fascinating example that I also want to spend 2 minutes talking a little bit more about, because it actually contains a lot of kind of hierarchical structure. So the first kind of clusters that that emerge are actually by language. So with the biggest cluster in this particular study also being in English. There's for sure some sort of data set bias also at work here. But then when you zoom in, let's say into this cluster of English language books, then you can see that on the next level, there's really clearly some, here the colors are related to the subject that the books were about. So in this kind of blue, pink, you can see science and technology books. They are kind of out here, a bit disconnected to the big bulk of literature from social science, politics, or literature. But this is not everything. You can even zoom in more. So you can go to the literature cluster and only look at those. And this alone is about 750,000 works. So, and then you can look at different subcategories in there. So, and if you want to look, for example, if you have a novel in the title, then these are up here. If there's play in the title, they are here. And then poetry and poems also form their own cluster. So there's something in the language representations of all these works that really kind of preserves them together in this visualization. And this is not everything. You can still zoom in further into this poetry cluster. You can, for example, then look into publication years. Here, color is publication year, and you can see that there's really a continuous evolution within this poetry cluster from in the last 200 years, forming like continuous relationships in this visualization. And then finally, if you zoom in one step further, and I think this is more or less it then. Oh no, there's one more zoom stage. Then you can find that different authors actually cluster quite strongly. And then even within the works of single authors, you can find that certain works or several editions of the same word form clusters in this visualization. So you can use tSNE for these kind of gigantic libraries to do explorative data visualization that helps you to understand relationships, neighborhood relationships, evolution over time of certain properties of the work, and explore these very high dimensional data that otherwise would be very hard to grasp, right? Otherwise you would have to, I don't know, read or look at the data representations of these of all of these several million books, which would be infeasible. And here finally there's more like an AI application. So here they looked at images from, I think, the ImageNet database, and based on the representation in a deep neural network, they visualized all these images. Okay, so far, any questions? Okay, I don't see anything typed into the chat window. Then I would just go on. Okay, after we now motivated why tSNE might be an interesting algorithm and looked at some applications, we will go a little bit more into the also mathematical details of tSNE. So tSNE is an example of a neighbor embedding algorithm. So naively, one could say, well, if I have data in a high dimensional space and I want to embed them into a two-dimensional space, what I should do is that I should simply find points in 2 dimensions that preserve as many of the pairwise distances between points in the high dimensional space as much as possible. So this is what is meant by this equation here. So xi and xj are the points in high dimensional space, other embedded points, and then this is the distance in the high dimensional space, and this I want to minimize. So I want to find a representation in 2 dimensions that captures all the pairwise distances in the high dimensional space as good as possible. This is at the heart of a actually very old method called multidimensional scaling. It's already over 70 or almost 70 years old. And the short version is it doesn't work. If you do multidimensional scaling on the MNIST dataset that we saw before, basically produces one giant blob that even has less structure than what PCA gives you. Why is that? The reason for that is that distances in high dimensional spaces is just in general, trying to preserve distances in high dimensional spaces is just in general a very bad idea, because it's just mathematically impossible to do so. So in a high dimensional space, the points are typically, it's very hard to imagine, but they're concentrated on a very narrow shell from the origin. And in 2, 3, 4 dimensions, this isn't so noticeable, but when you go to really 50 dimension or 200 dimensions or 500 dimensions, this becomes very clear. So what you can see here, for example, there's something in the Q&A. So there's one question: how do I apply your method to unstructured data like Twitter data sets to visualize varying public sentiments, opinions, and emotions? I would like to put that to the end of the presentation so that we can discuss that maybe at the end or even in the practical. So why doesn't it work? Well, what you can see here in this visualization is distances between points sampled from a standard Gaussian distribution in 2 dimensions, 50 dimensions, 500 dimensions, and then we just computed pairwise distances. And you can see that the distributions of pairwise distances is really, really quite narrow and lives on very different scales for the different dimensions. And because in 2 dimensions, this distribution is kind of centered here, and in 500 dimensions, it's centered here, you cannot simply map points in 500 dimensional space to 2 dimensional space while preserving all pairwise distances. So what do we do instead? A better idea is to preserve neighbors instead of distances. And this is the idea put forward by Jeff Hinton and Sam Roweis in 2003 in a method called stochastic neighbor embedding, which had some problems and was then extended by Lawrence Martin and Jeff Hinton in 2008 by appending the T in tSNE, which basically solves the problem of overcrowding in tSNE and really produces often very helpful visualizations. Now, how does it work? So this is kind of an illustration with some math of the tSNE algorithm. So this is some points, and now we would like to we start with a certain point I, and for that point I, we want to preserve in the visualization, we want to preserve its relationship with its neighbors. These are these points J here. The loss function for doing so in tSNE is the so-called Kullback-Leibler divergence between pairwise similarities in the high dimensional space and in the low dimensional space. I will explain this step by step. So Pij, these are the pairwise similarities in the high dimensional space, and then Qij, these are the pairwise similarities in the low dimensional space. Sorry. Okay. So how do we measure similarity in the high dimensional space? So these Pijs. we do that in a directed fashion by using a Gaussian kernel. So here, this is the Gaussian distance function, exp, the exponent of minus the distance squared divided by some kernel width. And this sigma here is important. This sigma is the kernel width, and in tSNE this is adaptively chosen to achieve a pre-desired perplexity. So the perplexity is p, which is equal to 2 to the h, where h is the entropy of this pj given I distribution, so of this directed measure. So basically, the parameter that you specify is perplexity, and then the algorithm automatically chooses which kernel width do I need here to achieve that perplexity. And we can see later what the effect of choosing different perplexities is. And then you symmetrize them, so you make these distance measures symmetric. Okay. So this is the high dimensional similarity, and then we need the low dimensional similarity. This is Qi, which is also again a kernel function applied to the low dimensional distance divided by some normalizing constant. And this low dimensional similarity kernel, this in tSNE, it was also this Gaussian distance, but in tSNE, this is actually the distance derived from a t distribution. And the advantage of that is that it has a slightly heavier tail. So it has some slightly different properties when creating the embeddings. Okay, so when you run tSNE on the MNIST dataset, you have to set this parameter perplexity. And this parameter perplexity, when you vary, for example, between perplexity 3 and perplexity 300, this is kind of the differences in the visualizations you get. When you have a low perplexity, then all the clusters kind of tend to stick together. And when you have a very high perplexity, things get really kind of moved apart, and there's more white space between the clusters. If you look at many implementations of tSNE, it looks like perplexity is really the only parameters. But actually there are others. So for example, the relative strength of repulsion and attraction. And this perplexity may not even be the most important one in practice. And I will show you how to choose some of the other parameters as well. So why is it important to have this t distribution, or it's also called a Cauchy kernel? When you don't do that, and this is what the method called tSNE did, then you get a crowding problem. And this you can see here. So you also see that then all these clusters tend to stick together a little bit like in our PCA visualization in the beginning. And when you use the t distribution instead, this really pushes things further apart. So where does this pushing apart or attracting, where does the structure come from? The structure comes from the particular form that the tSNE optimization algorithm is taking. So you have this loss function that we discussed. So this loss function here that measures the similarity between high dimensional distances and low dimensional distances. And then to optimize that, you take the derivatives and you use gradient descent to find an optimum. And optimizing this in tSNE really means placing all the points in the low dimensional space. These are the things that can be changed from iteration to iteration. Often, or many implementations actually start with a random configuration of points, but I will show you later that this is not a good choice. And if you have a physics background, this is reminiscent of kind of many body simulations. So the loss function takes a form where close neighbors in the original space, they attract each other, and distant points, they repulse each other. You can see that quite well when you look at the gradient of the tSNE loss. So, sorry, my pointer's gone again. Yeah. So these are the attractive forces. They are mainly at play between neighbors that are close to each other. And then these are the repulsive forces, and they are at play between points that are in the original space already quite far away. So we try to find an embedding that is optimal with respect to that cost function, which means we place the points in a way that, that neighbors stay neighbors and points that are far away are kind of placed somewhere. Is this rough idea of tSNE optimization, is that clear to everybody? No complete questions right now regarding that? Okay. Now there's a question, just a second. Okay, all clear, good. So this is a visualization. Maybe let me first tell you what you see, and then I will start it again. So here I show you an animated GIF that shows you what happens during such an optimization run. We start with a random initialization, and then we just run the optimization and do many of these gradient descent steps. And here you can see that during the optimization, here the representation of our nice numbers gets really kind of drawn into different directions. It's also interesting when you watch that over and over again, that you can really make out different phases with different dynamics. So here in the beginning, you have this very noisy phase, and then somehow things attract and repulse each other and move through space. Here you can see how these clusters move through one another, and then when they're kind of sorted by color, then they expand again until they reach an equilibrium of these attractive and repulsive forces with some white space in between here. So this is another data set. This is not MNIST. This is actually a data set with that we have also been working on quite extensively. This is genetic cell types in the brain. And if you just run these optimization, it's first of all, it's a lot of data. It's a couple 100,000 of cells. When you run this optimization, you can see that, and you initialize randomly, you can see that it really takes quite a while until the colors are sorted. So the colors are annotated for different big cell classes, and they really should be close to each other. And you can see this is really hard to achieve. So here in the end, even if you wait for long, the colors don't properly sort. So there's one trick. It's called early exaggeration, and you do that to, in the beginning, kind of get all the points that are similar or are neighbors in the high dimensional space closer together. So during the early phase of the optimization, you multiply all attractive forces by a constant factor, so 12, during the first 250 iterations. Of course, that's kind of arbitrary numbers, but when you do that, what's important is that the learning rate needs to be high enough. So there's a paper by Anna Berkina that studied that in detail. So when you do that, what you get is actually something very nice. So in the beginning, everything explodes, and then it expands again. But this making similar things more similar in the beginning, this helps the optimization to basically sort the different cell types by color. So you have this orange and red clusters down here. You have the pink clusters here, and then the blue-green clusters here. Now, this is still not perfect. So, for example, this pink and the rosé cluster here, they are still split by these others. And this, if this was a faithful representation of the data in the high-dimensional space, this shouldn't be the case because of the meta-knowledge we have about this data set. And there's a way to fix it. If you look into modern implementations of tSNE, there's two critical factors: how you implement the attractive forces and how you implement the repulsive forces to make it efficient. Because if you naively implement that, just write down this, the math in code, then you will be able to maybe find representations of like 2, 3, 4, 5,000 data points. And if you really wait long, maybe for 10,000 data points, but not for like what we've seen in the library data set or in the transcriptomics data set for 1 or 2 million data points. So to cope with that, just as a quick pointer, so you can use sparse approximate k-nearest neighbor graphs for the attractive forces. So you just say, okay, I'm just considering for every point, I'm just caring about the 20 nearest neighbors or something like this, or 10 nearest neighbors that I want to preserve. And for the repulsive forces, it's a little bit more complicated. There's various approximation schemes that you can use. And they basically go back to the idea that it doesn't matter. So if you have one point here and another point far away, or several points far away, it doesn't matter to exactly know the repulsive force from each of these points, but it's sufficient to kind of approximate that with the average repulsive force of these far away points. And there's, for example, one very widely adopted idea is this kind of tSNE. This is based on a Fourier transform accelerated interpolation of these tSNE forces. Yeah, of these repulsive forces. Now, as I already said, there's a problem with tSNE where global geometry is concerned. So here this is again our genetics data set. And what you can see in this PCA plot is actually what works very nice is that all these reddish, orange, pinkish colors are on one blob, all these greenish blue colors are on one blob, and all these dark colors are on one blob. And this is as it should be. So this is a certain class of neurons, this is interneurons, this is excitatory neurons, and these are non-neurons like glial cells. The details of this particular application don't matter, but what I just want to stress is that these colors mean something in terms of meta information that we have about these cells. When you look at the tSNE that we also just looked at in the default setting after optimizing that with otherwise well set parameters, so some early exaggeration, a well chosen perplexity, and so on, what you then see is excuse me, that you still get the separation of the pinkish reddish clusters by these bluish greenish clusters. And this is something that we would like to avoid. So, and this is an indication that PCA or that tSNE is actually very bad at preserving the global geometry of a data set. So what you can do to alleviate that issue is that you actually start out by the result from PCA. So the tSNE optimization is, of course, a very non-convex problem. There's a lot of local optima. And by using PCA instead of a random initialization, you kind of place your optimization algorithm already in a local optimum that is reasonably good with respect to the global optimization. tSNE still doesn't care about global constraints, but this is, if you want, it's a hack to make tSNE produce meaningful global structure. What you still should always avoid to do is reason about distances in this low dimensional embedding. So in the low dimensional embedding, only neighborhood relations matter, but it doesn't, you cannot say, for example, when you have the result of the embedding procedure in a second, you cannot say now here this point is further from this point than from this point. These distances don't really mean anything. You know? And even the cluster structure is something that you need to look at very carefully, as we will see in a second. So this, by the way, also works with very artificial data. So if your real data lies on a circle in some high dimensional space, and you do tSNE with random initialization, you get this kind of spaghetti monster kind of thing. And when you do tSNE with a PCA initialization, then you at least get this continuous line. The reason why this is still looking dented all over the place is that the circle is in a high dimensional space, and you somehow need to squeeze all that into lower dimensions. There's several other neighborhood embedding algorithms, and one very famous one is, for example, this algorithm called UMAP, Uniform Matrix Approximation and Projection. Sorry for the noise in the background. Or another algorithm called Force Atlas 2. And UMAP kind of received really a lot of attention in recent years, and was initially said, this is much better than tSNE, for example. For example, and one argument that was always made is that this is due to the fact that UMAP preserves global distances much better than tSNE. What we found out, or what Dimitri found out, that this is the difference between tSNE and UMAP with relationship to producing better global structure embeddings is really just due to the initialization. So the UMAP default implementation used PCA initialization or something similar, while the default tSNE optimization didn't. So people thought UMAP is better. But you can fix tSNE by just using the same initialization. And Force Atlas 2, the method that is especially used when data sets are studied that have some continuous structure. So let's say in evolution or things like that, or development or so. So what we wanted to understand is how are all these algorithms related, because they obviously have some common ideas, so that they try to preserve neighborhood relationships, but also some differences. And what we found is that there's actually a spectrum between all these algorithms. So on the one hand, there's tSNE. And on the other hand, there's a technique called Laplacian eigenmaps that really basically only looks at the at continuous variation. And depending on where you set the balance between attraction and repulsion, you get the similar outcomes to the different techniques. So UMAP is basically tSNE with slightly increased attraction. And Force Atlas is tSNE with strongly increased attraction. And Laplacian eigenmaps is tSNE with extremely strongly increased attraction. So these methods, all these neighborhood embedding algorithms, and there's also mathematical arguments that back this up. All these methods kind of form a continuum between tSNE and Laplacian eigenmaps. And depending on which one you choose to use for your data, this brings out different aspects of the structure. So tSNE is very good at visualizing cluster structure. So if you want to look at discrete aspects of your data, you choose tSNE. If you want to highlight continuous aspects of your data, so continuous variations between different parts of your data set, then you would rather use a technique like Force Atlas or Laplacian eigenmaps. Or you want to do some compromise in between, then you can also do that. But I think also maybe coming back to the discussion about the mechanism design for social good that was brought up earlier, I think what this makes clear is that the data analyst really has a choice in what aspects of the data he or she wants to emphasize on by choosing a particular algorithm. So this is just an illustration that this actually works. So here we start basically with the tSNE solution, and then by increasing the exaggeration, we obtain the UMAP solution. Okay, and with this, I'm done with the theoretical part on tSNE that I wanted to share with you. Now there was one question that was already put forward, and I'm happy to answer or to discuss also more questions. Maybe I look for a nicer slide to have in the background here. Just a second. Okay. So the question put forward here by Timitayo was, how do I apply your method to unstructured data like Twitter datasets to visualize varying public sentiments, opinions, and emotions? Could you maybe give me some detail on how such data looks like? Would that basically a tweet for every, or like the contents of a tweet with a timestamp or something like this?
So let them speak. You can unmute and ask your question or elaborate.
Okay. Are you still there? Well, I will say something with regards to the question, or what I think. So if the data here, if this Twitter data set would look, I haven't worked with social media data, to be honest, but if this is basically a tweet with a timestamp, then you would first compute some form of language embedding or word embedding. There are techniques to do that. Then based on this representation in the, so for example, a technique called word to WAG, and then on this representation, this is similar to what was done in the also in the book examples that I showed you, and then you compute this tSNE embedding, and then you get tweets that, you know, in 2 dimensions. And then you get tweets in two dimensions. And then if you have some way to assign kind of metadata, let's say public like sentiment analysis, if you, I don't know, highlight tweets where certain emotions are voiced or where certain topics are addressed, then you can look at where in that space they fall, or you could look at tweets of a single person and highlight all of these, or tweets of people from different countries or things like that, and use that to explore the data. So if you're interested in that and you actually work with Twitter data, please just contact me via email. We have also been working a little bit with text data, and I think that might be an interesting direction to look into. The other question that was just asked in the chat was, by Alessandro, are those methods appropriate for time series data? So if we have a huge number of time series, then we can, in a similar way, we can compute distances between type series in the high dimensional space and then embed them into a low dimensional space. So that's not a problem, as long as you can have some meaningful way to say what a distance between 2 data points is. Then this is entirely fine, also works for time series. You can also, if you meant with your question, that you would like to visualize time series in this embedding, then you have, let's say, longitudinal data and have measurements in different at different points in time, then one has to think a little bit about that, how one does that, so that in the end one gets an interpretable outcome, but also this can be done. So this was, for example, the case in the zebra finch study, where they looked at how song structure of these finches evolves. If you want to do that, then you can you sort of have, from the same bird, you have multiple songs over time during their learning period, and then you can embed that into 2 dimensions as well, and then look at trajectories of individual birds through that embedded space. So the difference between principal component analysis and this algorithm is that principal component analysis is a linear algorithm. Yeah? So it computes this direction of maximum variance and then performs a linear projection onto that direction. And tSNE is able to, it's basically a non-parametric technique. We just specify a cost function, namely that we want neighbors in high dimensional space to attract each other and points that are far away to repulse each other. And then we move the points around through optimization until these constraints are met. And so the relationship between the high dimensional and the low dimensional space is not anymore linear. It can be nonlinear, but it's not nonlinear in a parametric form, but actually in a non-parametric form. Okay, if there are no further questions now, I will stop my screen share. And then we will continue in half an hour. Is that right? Can one of the organizers maybe jump in?
Yeah, so thanks a lot for that. So there's a break for 30 minutes. Okay. People to grab some lunch, or depending on their time zone, take a little bit of a break. And then we'll reconvene in 30 minutes and continue with the practical session. Yeah, for information for the participants, there's a new link, there's a different link for the afternoon session.
Yeah, I will. Sorry.
Yeah, do you have something you want, a link to the notebook or something that you would want to share?
Yeah, so I just posted in the chat, I posted a link to a Google Colab notebook. And I will post it again in the next session. But my idea would be that basically I go through the Colab notebook and explain what you can see that in a screen sharing mode and basically show our examples. And then there are 4 tasks that you can then try on your own to vary some of the parameters. So then we start again in half an hour, is that right?
Yes.
Okay, awesome.
Good. All right, thank you. And thank you everyone for attending. Thank you very much, Philipp.
Sure.
Martin, do you have anything else you want to say? Or we can just call it a session? Or any of the other panelists?
Sheila, perhaps to let everyone know, I think the afternoon links are different from the morning.
Yeah, I think I'd already mentioned it, but yeah, it bears repeating. Everyone has a different link for the afternoon. Anything else? Okay, then see you in the afternoon, 30 minutes. Bye.
Bye.